In the hush of the universe's endless expanse, there lies a gentle call, not in sound, but in memory. It drifts through the folds of time, whispering stories from when the cosmos was young, when stars were still finding their light, and matter had only begun to dream of form. It is an invitation not made of urgency, but of wonder. A soft beckoning to close one's eyes and imagine a time when everything was simpler and infinitely vast. Before galaxies, before the dance of planets, there was only potential waiting to awaken into existence. The early universe was a sea of stillness, though hidden beneath that calm was unimaginable energy. It was not yet shaped into stars or dust, but it hummed faintly, like a song that had not yet chosen its melody. Through that delicate quiet, the first whispers of structure began to form: hydrogen and helium, the simplest of all elements, coming together in invisible harmony. They would one day become the building blocks of everything familiar, but in that age, they were only shy beginnings in a grand cosmic story. As the darkness stretched across an expanding space, faint glimmers began to appear, soft and uncertain. The first light, not the fierce blaze of modern stars, but the shy flicker of the earliest galaxies, brushed across the black canvas. It was like watching a night sky being painted one breath at a time. These lights did not burn bright, they shimmered quietly, as though aware of the delicate balance they were disturbing in the silence of eternity. Those first galaxies were fragile, smaller than the giants we see today, scattered like dew on the web of space. They formed in a universe that was still finding its rhythm, drawn together by gravity's unseen hand. Within them, the first stars ignited, fierce and brief, like sparks in cold wind. They lived fast and died violently, seeding their surroundings with the raw materials that would one day give rise to more complex wonders, planets, moons, and perhaps, much later, life itself. Every burst of light in that ancient time was a story of creation and loss. The early stars, massive and unstable, burned through their fuel in moments compared to our sun's long life. Yet, their deaths, their explosions, were gifts. They enriched the cosmos with heavier elements, scattering the seeds that would later form rocky worlds and shimmering clouds. In their endings, they ensured that the universe would not remain empty, but filled with color, texture, and endless possibility. The young galaxies gathered slowly, their shapes still uncertain, their centers glowing with newborn stars. Around them, darkness pressed close, but the light kept spreading, gently pushing back the veil. The universe, still small in age, was already ancient in mystery. Time itself seemed to move differently, slower, softer, as if the cosmos were taking a deep, patient breath before exhaling into complexity. Through these tender beginnings, gravity became the sculptor of the grand design. It drew filaments of matter together, weaving them into vast cosmic webs. Along these threads, galaxies formed in clusters, each influencing the other in subtle, elegant ways. The fabric of the universe began to look like a living thing, interconnected, pulsing with motion, filled with hidden patterns that echoed through billions of years. In this grand stillness, the light of the first galaxies continued to travel. Some of it has not yet reached us, still crossing the vast ocean of space-time. What we see today when we look at distant galaxies is not their present, but their youth, frozen moments in the universe's long journey. Each photon that touches our eyes tonight might have been born when the universe was only a fraction of its current age, carrying with it a story that began before Earth ever existed. And so, when we gaze into the dark sky, we are not merely looking outward, we are looking backward through time itself. The further we peer, the younger the universe becomes. It's as though the night sky were a tapestry woven from history's oldest threads, each glimmer a reminder that what once was still lingers in faint, luminous whispers. Every star, every shadow, is a fragment of the universe's earliest thoughts. The silence of space is deceptive. Beneath it, every atom hums with memory. The galaxies that formed in that ancient dawn are still speaking to us in radio waves, in light stretched to redness by expansion, in the quiet rhythm of cosmic background radiation. These are echoes, not of destruction, but of creation itself, the lingering warmth of the moment when everything began to take shape. The cosmic microwave background, that faint afterglow left over from the universe's earliest light, is like the first lullaby ever sung. It hums quietly in every direction, a soft reminder that even in vastness, there is connection. When scientists listen to it, They are, in essence, listening to the universe's first breath, that moment when energy became matter and darkness first met light. It is humbling to think that those ancient galaxies, now faint specks at the edge of our telescopes, once blazed with the brightness of beginnings. Their light took billions of years to find us, threading through endless voids to reach human eyes. And when it finally does, we become witnesses, quiet observers of a history too grand to measure, too ancient to fully comprehend. In the vastness of those early moments, chaos and order danced side by side. Gravity pulled, radiation pushed, and somewhere between them, balance emerged. The universe did not rush, it unfolded slowly, as if savoring every detail of its creation. Even now, it continues to expand, a quiet echo of that first outward breath, stretching farther and farther into an unknown future. From those first galaxies came generations of new ones. They collided, merged, and grew, their shapes evolving like living things. Spiral arms unfurled, dense cores ignited, and the cosmos filled with motion. Every encounter left behind beauty, streams of stardust, luminous bridges, and starburst regions where new suns were born in clouds of color. And yet, despite its immensity, the early universe carried a strange intimacy. Each atom, each beam of light, played a role in the unfolding story. The same carbon and oxygen born in those first stars would one day form the air of future worlds. The same hydrogen that flowed through the first galaxies would one day fuel suns like our own. In that sense, the deep past never truly left us. It lingers within and around everything that exists. It is easy to imagine the early universe as violent and chaotic, and it was, in its way, yet beneath that energy lay an elegance. Every collapse of a star, every swirl of gas, every forming cluster followed the quiet laws of physics, like steps in a cosmic dance choreographed by time itself. Out of seeming disorder, symmetry and beauty emerged. The universe was not random, it was art unfolding. As eons passed, the young galaxies matured, forming the structures that would become the backbone of the cosmos. Supermassive black holes awoke in their centers, drawing in light and matter, shaping the motion of stars around them. Even in darkness, creation persisted, a paradox that defines the universe itself. Out of the void came everything, out of silence came song. When we trace this story today, through telescopes that reach across time, we are not just studying physics, we are listening. The early universe speaks in light and shadow, in color and distance, in the faint echoes that shimmer across the night. It reminds us that we are part of a continuum far greater than ourselves, born from the same dust that once circled newborn stars. And so, to accept the invitation to the deep past is to close one's eyes and let the mind drift backward, past the familiar stars, past the Milky Way's arms, into that ancient glow where the first galaxies lived and died. It is to feel the slow heartbeat of the cosmos and to know that even in silence, there is endless storytelling. The universe's beginnings are not lost. They are all around us, in the air we breathe, the light we see, the atoms that make our hearts beat. Each moment carries within it the echo of that first awakening, that quiet invitation from the deep past, still unfolding softly across the infinite night. Light, though weightless and silent, is the most faithful storyteller of the cosmos. It travels across the endless dark, untouched by the passing of eons, carrying within its waves the memories of where it has been. When it reaches us, it does not only illuminate, it reveals. Every photon that touches our eyes or the mirrors of our telescopes has journeyed through time, becoming a message from a distant age, a small piece of history still burning across the cold expanse of space. To look at the stars is to look backward. The light from our sun is already 8 minutes old when it reaches us. From nearby stars, it may be years, and from distant galaxies, millions or even billions of years have passed since that light began its journey. In this way, the universe presents itself not as it is, but as it was. Every night sky is a museum of time, its walls painted with the relics of ancient light, each glow a record of a moment long gone. This simple truth, that light takes time to travel, transforms the act of looking into a form of time travel. We cannot see the present of the cosmos, we see its layered past, each distance revealing an older chapter. The farther we look, the younger the universe becomes, until eventually, our gaze reaches an age before stars existed at all. In that way, Our telescopes are not just instruments of sight but of memory, peering into the dawn of everything. The galaxies that shimmer faintly in deep-field images are not distant in space alone, they are distant in time. Their light began when the universe was still young, before the Milky Way had even formed. What we observe now is their youth, frozen in luminous echoes. Some of those galaxies may no longer exist as they once were, they may have merged, shifted, or faded. But their light remains, crossing the cosmic sea long after their forms have changed. When astronomers point powerful telescopes toward the heavens, they are not merely observing, they are resurrecting ancient light. The faintest smudge captured in an image might represent a galaxy as it was more than 13 billion years ago. Through such light, we glimpse how the first stars ignited, how elements were born, and how structure arose from the chaos of creation. Each photon becomes a messenger, whispering stories from before humanity even dreamed of the stars. This connection between light and time gives the universe its layered beauty. Imagine space as a vast ocean, each ripple a moment in time moving outward. The further one sails, the older the waters become. To gaze into deep space is to dive into ancient waves, to feel the quiet pulse of beginnings beneath the surface of now. We are swimmers in time's current, surrounded by light that has been traveling since before our planet had form. It is through this ancient light that we know what the early universe looked like. The faint glow captured by observatories such as the James Webb Space Telescope shows galaxies forming mere hundreds of millions of years after the Big Bang. Their stars, young and fierce, shine through clouds of dust and gas, painting the darkness with color for the first time. These are the first storytellers, their light still making its way to us, crossing billions of years to reveal their brief brilliance. Light carries not only distance but transformation. As the universe expands, it stretches the light traveling through it, shifting its wavelength toward the red end of the spectrum. This redshift is more than a phenomenon, it is a language of time itself. The redder the light, the older it is, the farther it has traveled. In every photon's fading color lies a record of expansion, a cosmic signature of the universe's ongoing journey outward. To read that light is to read history written in motion. Astronomers use these subtle shifts to measure how far away galaxies are and how quickly the universe has grown. In doing so, they trace a map not just of space, but of time, a timeline woven from light's patient endurance. Each measurement reveals more of the universe's long memory, its quiet unfolding. Written across billions of light-years. It is humbling to realize that even the faintest glow visible through a telescope represents unimaginable persistence. Those photons have crossed regions of emptiness wider than our comprehension, unbroken by the gravity of black holes, unbent by time's erosion. They have traveled faithfully since before our species existed, only to meet a mirror, a lens, or an eye, completing a journey that began when the cosmos was still learning to shine. When we see a distant star twinkling, we are witnessing an illusion of the present that is truly a glimpse into the past. The star may have changed, dimmed, or even vanished since its light began traveling toward us. Yet the light remains, and through it, the star still lives, a ghost of energy lingering in our sky. In this way, light defies loss, it becomes a form of remembrance, a bridge between what was and what remains. The night sky is thus not merely a scene but a story unfolding in reverse. The closer stars tell recent tales, while the faint, distant galaxies recount the universe's first moments. As we gaze deeper, the light thins, until eventually we approach the edge of what can be seen, the afterglow of the Big Bang itself, the first light to ever move freely through space. Beyond that, there is only darkness, a time before light had been born. In this sense, every telescope is a time machine, each lens and mirror a window into an older universe. The photons they capture are fragments of ancient moments, frozen in their flight. With every observation, we rebuild the past piece by piece, reconstructing the cosmic narrative from scattered traces of light. Science becomes a form of listening, not to sound, but to the visual music of time. Even our own planet is part of this luminous connection. The sunlight that warms our days carries within it the story of fusion, hydrogen atoms combining deep within the sun's heart, releasing energy that travels for thousands of years before escaping its surface. Only then does it begin the brief journey to Earth. The light on your skin today may have been born inside the sun before any human civilization existed. When we hold light in our understanding, we hold the past in our hands. Each color, each flicker, is a record of what once was. Astronomers unravel these records to learn not only about distant galaxies but about ourselves, how the elements of our bodies were forged in ancient stars whose light still wanders through space. We are, in every sense, children of light, shaped by its slow passage through time. The connection between light and memory extends beyond science. It touches something profoundly human. To know that every star we see might already be gone, and yet still visible, teaches us that existence is not defined by the moment but by what it leaves behind. The light we send into the world through action, thought, and love might also outlast us, traveling farther than we can imagine. And perhaps that is why we find comfort in the stars. They remind us that the past never truly disappears, it merely travels onward, transformed by distance and time. The light from ancient galaxies still glows softly in the night, reaching across epochs to meet our gaze. In that meeting, the boundary between past and present dissolves, and for a brief, beautiful instant, we stand connected to the beginning of everything. The universe, then, is not a static expanse but a river of time, flowing outward in waves of light. Every photon is a ripple carrying history forward, every reflection a reminder of endurance. To study light is to follow these ripples back to their source, to understand that all we see is only the latest surface of a much older sea. And so, when we lift our eyes to the night sky, we are not standing in the present but suspended in a collage of times. The stars above are not what they are, but what they were. The galaxies that glow faintly on the edge of our vision are memories made visible. Light makes it possible for us to wander through those memories, traveling not with engines or ships, but with sight and imagination. It is a quiet miracle that something so intangible can bridge such immense distances, linking the newborn universe to the human heart. In every shimmer of starlight, there is both science and poetry, both knowledge and wonder. Light does not simply reveal the universe, it connects us to its soul, showing that even across the deep gulf of time, beauty endures. And as we watch it arrive, billions of years after it began, we too become part of the story. Our eyes, our instruments, our curiosity, they are the final stop in a photon's long voyage. In that meeting of ancient light and human awareness, the universe learns to know itself, and for a fleeting moment, past and present touch, glowing softly together in the dark. When we picture galaxies today, we often imagine graceful spirals, swirling arms of starlight curling around bright hearts. But the first galaxies were nothing like that. They were not elegant or grand, but raw and untamed, scattered sparks in the darkness. The early universe was still young, its matter uneven, clumped here and stretched thin there. Gravity was only beginning its long work of gathering those scattered bits into islands of light. What emerged first were chaotic forms, fragments of what would one day become the majestic spirals and ellipticals we know. These primitive galaxies were small, fragile, and turbulent. They flickered rather than glowed, their stars burning fast and hard in a storm of gas and dust. There were no smooth arms yet, no steady centers of rotation. Instead, they were irregular clouds of energy like cosmic campfires struggling to stay alight in a cold, endless night. Their light was the first attempt of the universe to illuminate itself, the first defiance of darkness. Each spark was a beginning, a tiny act of resistance against the void. Within them, the first stars were born, massive, short-lived, and immensely bright. These early stars lived only a few million years, a blink in cosmic time, before collapsing or exploding, sending their elements outward into the waiting dark. Their deaths enriched the space around them, seeding future generations of stars with the materials for complexity, carbon, oxygen, and iron. The collisions of these small galaxies were constant and chaotic. Gravity, the great sculptor, was pulling them together and tearing them apart at the same time. When they met, they merged in bursts of light, forming new stars in violent waves of creation. From these collisions, larger galaxies began to grow, piece by piece, over billions of years. The universe was building itself slowly, like a painter layering color upon color to form a masterpiece. If one could have stood among those early galaxies, the view would have been breathtaking and strange. The skies would shimmer with clusters of newborn stars, their light filtered through thick clouds of gas. Vast regions would glow faintly where stars had recently died, their remnants spreading like mist. There would be no familiar constellations, no patterns of order, only beauty in chaos, only creation in motion. These galaxies did not yet spin gracefully. Their gravity was still learning balance. Some were shaped like lopsided blobs, others stretched into threads by tidal forces. Each one told a story of growth and struggle, a step in the long evolution toward structure. Over time, as more stars formed and died, as more matter gathered, their shapes began to settle. But in those first billions of years, they were living storms of light. From the perspective of the universe, this era was one of experimentation. Not every clump of gas became a stable galaxy. Many were torn apart, their contents scattered back into the cosmic web. Others merged too quickly, collapsing under their own weight. Only a few survived long enough to evolve into organized systems. The rest lived and vanished quietly, their light fading like embers at the edge of a cosmic fire. Even in their disorder, these scattered sparks played a crucial role. They were the first factories of starlight, the first places where matter found purpose. The elements forged within them became the foundation of everything to come. Every world, every moon, every atom in our bodies traces its origin to those unruly beginnings. The chaos of that age was not wasteful, it was essential. It was how the universe learned to create. The light from those early galaxies still travels toward us today, stretched thin by the expansion of space. When we capture it with our telescopes, we see them as they were messy, luminous fragments scattered across a vast canvas. Some are so faint that they barely exist as more than a smear of light. Yet within each smear is history, billions of stars, each one born and extinguished long before Earth existed. As we study these faint smudges, we learn that beauty does not always mean perfection. The early galaxies, in their irregular forms, were proof that creation begins with imperfection. It is from the raw and unbalanced that harmony eventually grows. The grand spirals we admire today are simply the matured descendants of those first, scattered sparks, older, calmer, more graceful, but carrying the same fire at their core. The universe's first era of galaxies was like a chaotic orchestra warming up before the symphony. Each small galaxy was an instrument tuning itself, releasing bursts of sound or light before the full harmony emerged. Over billions of years, as they collided and combined, the notes began to blend, forming the music of the cosmos we now hear in every corner of the night sky. It took time, unimaginable stretches of time, for the scattered sparks to settle into the galaxies we see today. The cosmic web thickened, and clusters of galaxies formed at its intersections. The delicate threads of gravity connected everything, drawing light into patterns that still define the structure of the universe. The once isolated sparks became part of a grander design, each one contributing to the collective glow of creation. And yet, some of those early galaxies never grew. They remained small and dim, quiet relics of the universe's youth. Astronomers call them dwarf galaxies, and they still drift near larger ones like the Milky Way, ancient survivors of that first age. Studying them is like finding fossils from the universe's childhood, preserved reminders of what once was before order and size dominated the heavens. Inside those tiny galaxies, stars still burn today, though faintly. Their light tells us that even the smallest sparks endure. They may not have grand shapes or luminous arms, but they carry stories billions of years old. Each faint glow is a heartbeat from the dawn of time, still pulsing softly in the dark. They are proof that even in vastness, nothing born of light is ever truly lost. As galaxies merged and evolved, new kinds of stars began to appear, smaller, steadier, longer-lived. They would shine for billions of years, unlike their short-lived ancestors. Around these stable stars, dust gathered into disks, and within those disks, the seeds of planets began to form. The scattered sparks had become gardens, places where light and matter could weave together into something more intricate, something capable of dreaming. By then, the universe had grown quieter, cooler, more structured. The violent births of the first stars gave way to gentler rhythms. Spirals began to curl, symmetry began to appear, and the cosmos took on a sense of calm. Yet beneath that serenity lay the memory of its wild beginnings, of the scattered sparks that had once burned without pattern or rest. Their chaos was the foundation of all peace that followed. In a way, every galaxy carries within it the story of those first ancestors. The Milky Way itself was born from countless smaller collisions, the merging of many scattered sparks into one great body. Our home in the universe is the product of ancient turmoil, a testament to how disorder, given time, can shape beauty. What once was broken and scattered became whole, spinning gently through the ages. When we gaze at distant galaxies through the eyes of our telescopes, we are looking back at the moment before order, before grace. Those faint lights, stretched and dimmed by time, show us what the universe looked like when it was still learning the art of structure. They are the first sketches before the masterpiece, the first words of a poem that would one day become the story of stars, planets, and life. In their uneven glow, we can sense the rhythm of creation, not deliberate, but organic, like waves forming patterns in the sand. The universe was not built all at once. It grew through trial, through collision, through constant change. The scattered sparks were not flaws in the process, but its very essence. From them came everything: galaxies, worlds, and us. And perhaps that is why their light feels so hauntingly beautiful. It reminds us that beginnings are often messy, that brilliance is born from struggle. The early galaxies were not perfect, but they were alive in a way that only new things can be: uncertain, blazing, fleeting. Their energy still echoes through us, for we, too, are the descendants of scattered sparks. Even now, billions of years later, the night sky carries their memory. Every point of light is a continuation of that first chaos turned to order, that first darkness turned to glow. The galaxies above are not merely ornaments in space, they are living fossils of creation's earliest fire. When we look up, we are not just seeing stars, we are seeing the scattered sparks that began it all, still burning softly across eternity. The universe, once quiet and cooling, began to stir again as vast clouds of hydrogen and helium gathered under the invisible pull of gravity. These immense reservoirs of gas were restless, swirling and collapsing under their own weight. Inside them, pressure mounted, and temperatures climbed to extraordinary heights. What had been calm and formless began to tremble with purpose. These were the wombs of stars, immense, storming regions where chaos and beauty intertwined, where light itself was about to be born again. The gas was not evenly spread. Pockets of density formed like knots in an infinite mist, places where gravity had the advantage. These knots grew heavier, drawing in surrounding matter, spinning faster as they collapsed. Inside these dense cores, atoms collided so fiercely that their energy overcame repulsion, and fusion ignited for the first time. In that moment, the universe became brighter, dotted with new suns blazing into existence. It was a frenzy of creation, furious, radiant, unstoppable. Each newborn star was a small explosion of light against the darkness, a promise that the cosmos was not fading but still unfolding. Around these young stars, shockwaves rippled outward, disturbing nearby gas clouds and triggering even more star formation. It was a cascade, one birth leading to another, like sparks leaping from fire to fire. The universe had entered its most vigorous era of creation, an age when stars formed faster than at any other time in history. The light from these early stars poured into the surrounding space, breaking apart the fog of neutral hydrogen that once cloaked the cosmos. This great reawakening is known as the epoch of reionization, when light reclaimed dominance over darkness. Every photon streaming outward was not only illumination but transformation, reshaping the chemistry of the universe itself. The first great glow after the long night had begun. But this brilliance came at a cost. The early galaxies were turbulent, violent places. Their gas was constantly heated by the fury of young stars and supernovae. Shockwaves rolled through them, mixing elements, scattering dust, and sometimes blowing matter entirely out into intergalactic space. The birth of light was inseparable from destruction, every star a balancing act between creation and collapse. Amid the violence, beauty bloomed. The explosions of dying stars scattered heavier elements, enriching the clouds that would later form new stars and planets. Carbon, nitrogen, oxygen, the ingredients for life, all came from those furious beginnings. What looked like chaos from afar was, in truth, a process of refinement. The universe was learning to craft complexity, to weave richness from its primal materials. The first great clusters of stars formed during this era, dense, glittering cities of light bound together by gravity. Within them, countless stars burned in every stage of life, some newborn and blue-hot, others dying in silent red embers. These clusters would drift for billions of years, surviving long after their host galaxies changed or disappeared. Some of them still hang in the night sky today, relics of that wild, fertile time. Gas continued to flow through galaxies in enormous rivers, feeding star formation like veins carrying blood. In some regions, vast sheets of gas collided head-on, compressing into brilliant starburst zones where thousands of stars ignited almost at once. These were the cosmic nurseries, glowing patches of pure energy, surrounded by storms of radiation. They were both cradles and furnaces, forging light while consuming their own foundations. The gravity of young galaxies kept pulling more matter inward, but their restless stars often pushed it back out. Winds of radiation and gas flowed away from galactic centers, shaping their forms and slowing their growth. The battle between inward pull and outward blast defined this era, a dance between collapse and expansion, order and chaos. The result was diversity. No two galaxies looked the same, and each one told a unique story of how it had survived its own turmoil. From the heart of some galaxies, something darker and more mysterious began to stir, the birth of supermassive black holes. As gas fell toward these invisible giants, it heated to unimaginable temperatures, creating jets of light and radiation that could outshine entire galaxies. These young black holes were both destroyers and sculptors, regulating how many new stars could form. They were the silent architects of galactic destiny. In the midst of all this, gravity continued its quiet work. Small galaxies merged with larger ones, bringing fresh supplies of gas, reigniting waves of star birth. Every collision was both an ending and a beginning. The structures we see in the universe today, spirals, ellipticals, and clusters, are the children of those ancient mergers, shaped by the furious blending of matter and light. The newborn stars themselves were unlike most we see today. Many were massive, dozens or even hundreds of times the size of our sun. They lived brilliant but short lives, burning through their fuel in only a few million years. Their light was harsh, ultraviolet, capable of transforming entire galaxies. When they died, they exploded with titanic force, leaving behind neutron stars or black holes, the first heavy remnants in the cosmic graveyard. Those explosions sent shockwaves across space, compressing nearby clouds into new stars. In this way, death always fed birth, and destruction became a path to renewal. The balance between creation and ruin defined the rhythm of the cosmos. It was not a gentle nursery, but a raging forge, and yet from that fury came everything that would one day soften into calm, into planets, oceans, and quiet skies. Even in that early chaos, patterns began to emerge. Streams of gas traced elegant arcs through galaxies, guided by invisible filaments of dark matter. These unseen structures formed the scaffolding on which galaxies grew, holding everything together while remaining themselves unlit. The luminous world was built upon the skeleton of the unseen, and without that framework, the stars could never have found their places. Astronomers studying this distant time use telescopes to capture the faint light from those furious epochs. What they see are galaxies ablaze with energy, their spectra rich with emission lines from hot gas and newborn stars. Each image is a frozen instant of cosmic fire, preserved across billions of years. It reminds us that the tranquil sky above our world was born from unrelenting violence and motion. Over time, the storm began to quiet. The gas supplies that fueled star formation were consumed or expelled, and galaxies began to settle into more stable shapes. Spirals emerged, their arms tracing paths of older stars, while elliptical galaxies grew large and red, their days of furious creation behind them. The universe had entered maturity, its youthful chaos replaced by structure and grace. But the echoes of its wild youth still glimmered faintly in every corner. Yet even as star birth slowed, the remnants of that earlier age persisted. Dust clouds still floated between stars, holding within them the ashes of countless supernovae. From those ashes, new systems continued to form, smaller, calmer, but still children of the same primordial fire. Our own sun was born in such a cloud billions of years later, inheriting the chemistry crafted by those ancient explosions. The heavy elements scattered through those turbulent ages would one day shape life itself. The iron in blood, the calcium in bone, the oxygen in breath all came from stars that lived and died during the universe's most frenzied age. Each atom inside us carries the signature of that time, forged in heat, cooled in chaos, and passed through generations of cosmic creation. The galaxies that endured through those epochs carry scars of their past, tidal tails, warped arms, glowing cores still fed by ancient black holes. To look at them is to see memory written in light. Every flicker, every burst, is an echo of the turbulence that once filled the cosmos. The quiet we see now is not absence but aftermath, the long sigh after the storm. The process never truly ended. Even today, star-forming regions continue their furious work in hidden corners of the universe. Nebulae within our own galaxy, like Orion and Carina, are miniature reflections of those first great nurseries, still glowing, still birthing. They remind us that creation is not confined to the past, it continues in silence, in patience, everywhere light dares to emerge. What began as turbulent gas became the foundation of everything we know. It was the raw material from which stars, worlds, and eventually minds would arise. The universe was not peaceful when it began its work, it was stormy, untamed, alive with motion. And from that motion came beauty beyond measure, order born from fire, calm born from chaos. So when we look at the night sky, serene and still, we are seeing the calm after an ancient tempest. The light of those stars, steady and quiet, is the echo of an age when creation was wild and relentless. The cosmos still carries that energy within it, not gone, merely slowed. Every glimmer overhead is a reminder that from turbulent gas and furious star birth, existence itself was born, still glowing softly in the long, dark night. In the vast quiet of space, where galaxies drift like lanterns on an invisible sea, collisions are inevitable. Yet, unlike the violent crashes we imagine, these encounters are slow, almost graceful, unfolding over billions of years. Two galaxies approach each other like dancers drawn by unseen rhythm, their motions guided by gravity's tender insistence. From a distance, the process seems serene, a slow intertwining of light and motion, emerging not of destruction, but of transformation. As the galaxies draw near, their stars do not collide directly, the space between them is too immense. Instead, their mutual gravity begins to distort them, stretching spiral arms, pulling gas and dust into long tendrils that shimmer like silk across the dark. It is a cosmic ballet where matter responds to invisible currents, and the shapes of galaxies change as if they were alive, bending and folding in elegant surrender to each other's pull. Inside these merging galaxies, chaos brews. Clouds of gas collide, compressing under the force of motion. New stars ignite in sudden, brilliant waves, lighting up the merging systems with bursts of blue-white radiance. These are starbursts, short-lived but magnificent episodes of furious creation. The galaxies, once distinct, now share their light, their gas, their very essence, fusing into something entirely new. Gravity weaves this union slowly, patiently. Over millions of years, the two galaxies spiral closer, their centers circling each other like companions locked in eternal embrace. Each orbit draws them tighter, and with each pass, more stars are cast outward into tidal streams, thin ribbons that will drift across intergalactic space. Long after the merger is complete, these stellar trails are the faint handwriting of cosmic history, visible reminders of what once was separate now becoming one. Sometimes, one galaxy is far larger than the other, swallowing it in a quiet act of cosmic cannibalism. These minor mergers are more common than the grand collisions between equals. The smaller galaxy is gradually stripped of its stars and gas, its pieces absorbed into the larger host. Yet even in this, there is no malice, only gravity's endless patience, gently blending one structure into another, until the smaller is not lost, but remembered in the glow of the greater whole. When two galaxies of similar size meet, the event becomes far more dramatic. Their combined gravity reshapes both, flinging gas into great arcs, igniting countless new stars, and heating clouds until they shine. Over time, the distinct forms of spirals fade, replaced by a more rounded, elliptical structure. These mergers give birth to massive galaxies, ancient and red, filled with older stars that burn more quietly than the youthful bursts that preceded them. At the heart of every large galaxy lies a black hole, and when galaxies merge, so too do these dark centers. They spiral toward each other over eons, radiating invisible waves of gravitational energy as they draw closer. In their final moments, the two black holes combine into one, a single, more powerful heart pulsing at the core of the new galaxy. The merger of darkness becomes the foundation of new order, binding the system together. Even as these galactic unions transform the cosmos, they shape the fate of stars and planets within them. Some stars are thrown out into deep space, forever exiled into the cold. Others find themselves in new orbits, carried to distant reaches of their galaxy's expanding arms. For any world that might circle those stars, the night sky would change over generations, new constellations forming as galaxies glide into one another's embrace. The light from merging galaxies travels across the universe to us, carrying snapshots of the process frozen in time. Through telescopes, we see their distorted forms, arcs, loops, and glowing bridges connecting them. The famous antennae galaxies, for example, are caught mid-merger, their long tails of stars stretching like brushstrokes across space. They remind us that creation often hides within destruction, and beauty thrives even amid collapse. Over cosmic history, mergers have been the architects of growth. No galaxy exists untouched by them. Even our own Milky Way is a product of many such unions, each one adding to its mass, reshaping its form, and enriching its stars. The quiet arms that we see today are not ancient originals but the polished result of countless collisions, gentle echoes of the universe's restless need to come together. And this process is not finished. In 4 billion years, the Milky Way will merge with the Andromeda Galaxy. The two are already on a slow, inevitable path toward each other. When they finally meet, their stars will swirl together in vast, luminous currents. From Earth, or whatever worlds may exist then, the night sky will blossom with light, a vision of two great galaxies entwined like glowing rivers across the heavens. Despite the grandeur, the merger of galaxies rarely destroys their stars. The true violence happens in the clouds of gas, where collisions ignite new generations of suns. The stars themselves glide past one another like ships in a vast ocean, feeling only the subtle tug of changing gravity. What is destroyed are the boundaries, the sense of separateness that once defined each galaxy. What is born instead is unity, a new structure, older and wiser in its cosmic age. Galactic mergers also shape the rhythm of the universe's expansion. As structures grow larger, gravity slows their drift, forming clusters of galaxies bound together in immense webs. Within these clusters, mergers continue endlessly, each one a small note in the grand symphony of evolution. From afar, these regions glow faintly, like constellations made not of stars, but of entire galaxies intertwined in motion. Astronomers studying mergers often speak of them as conversations between galaxies, long, drawn-out exchanges where gravity is the language. Each interaction transfers energy, momentum, and light, changing both participants forever. No galaxy leaves such an encounter unchanged. The faintest dwarf to the largest elliptical all carry scars and signatures from past collisions, the fingerprints of time etched into their shapes. The story of mergers is, at its heart, the story of connection. In the endless void, galaxies do not remain isolated for eternity. Ages passed, the frequency of mergers declined. The expanding universe stretched the space between galaxies, making encounters rarer. But they did not cease. In the densest regions, clusters and superclusters, galaxies still drift close enough to feel each other's pull, still begin the slow dance that will one day end in union. The cosmos continues its quiet choreography, one embrace at a time. When galaxies merge, their forms tell the tale. Some emerge smooth and rounded, glowing red with ancient stars. Others retain hints of their spirals, delicate whirls of light lingering like memories of youth. In every shape, there is history, a visual record of balance and change. The universe paints its story not in words, but in these immense, glowing forms drifting through the dark. The energy released during these mergers often awakens the sleeping hearts of galaxies. Black holes, long dormant, flare back to life as gas spirals into them, creating brilliant quasars visible across billions of light-years. For a brief moment, the new galaxy shines brighter than 1,000 normal ones combined. Then, as the energy subsides, the light fades, leaving behind calm, and the quiet rhythm of rotation begins anew. From the smallest collision to the grandest fusion, the laws of physics remain patient and precise. Nothing is wasted, every disruption becomes part of a larger pattern. Mergers recycle matter, spread elements, and reignite the fires of creation. Without them, the universe would have stagnated, locked forever in static forms. Instead, through these gentle collisions, it renews itself endlessly, ensuring that even in decay there is rebirth. And so, when we look upon images of colliding galaxies, we are not witnessing destruction but transformation. The bright arcs, the twisted filaments, the glowing bridges, all of them are symbols of change, of the universe's eternal reshaping of itself. Time turns violence into grace, and from what seems chaotic, symmetry emerges. It is a process both merciless and merciful, a lesson written in light. The stars scattered by mergers will continue their journeys through the void, some never to return. These wandering suns, drifting between galaxies, are the nomads of creation. They carry with them the light of lost homes, tiny reminders that even in the aftermath of great unions, individuality persists. The universe holds space for both the collective and the solitary, the merging and the wandering. Over billions of years, these gentle collisions have built the cosmos we see today. Every massive galaxy is a monument to countless mergers, every cluster a gallery of completed dances. And though we often think of the universe as still, it remains alive with movement, each light in the sky part of a story still unfolding, each gravitational pull a note in an endless, cosmic waltz. In the end, galactic mergers are the heartbeat of creation, a rhythm that pulses across the ages. They teach us that union need not mean loss, that even the most powerful collisions can be acts of grace. Out of every meeting comes something new, brighter, larger, and richer in history. In their slow, dark embrace, galaxies remind us that the universe's greatest beauty lies not in isolation, but in connection. And so, across the deep night, the dance continues. Galaxies drift, collide, and merge in silence, reshaping the tapestry of the cosmos one luminous thread at a time. Their light travels outward, reaching the eyes of distant observers billions of years later, us, who, by witnessing, become part of the story. We, too, are drawn into the same cosmic rhythm, quiet participants in the slow, eternal merging of all things into one. Before the first galaxies shone clearly, the universe was shrouded in a deep and endless fog. This mist was not made of water or vapor, but of neutral hydrogen, countless atoms drifting through the vastness, unilluminated and cold. It was an age before clarity, before structure, before the cosmos had truly opened its eyes. To look upon it then would have been to see nothing at all, for light itself could not travel far in this opaque expanse. It was a universe asleep, holding its breath before the dawn. Within this cosmic fog, the seeds of light were quietly gathering strength. Tiny fluctuations in density, faint ripples left behind by the Big Bang, began to pull matter together. Gravity, patient and tireless, coaxed hydrogen clouds to collapse into the first stars. They were unlike the stars we know today, massive, short-lived, and unimaginably bright. Their light struggled to push through the haze, but with each flare of fusion, the fog thinned a little more. The first sparks of illumination began to whisper across the darkness. The moment one of these primordial stars ignited, the universe changed forever. Ultraviolet radiation streamed out in all directions, ionizing the hydrogen gas that surrounded it. The fog began to lift, not all at once, but in growing patches of clarity. Around each young star, a bubble of transparency expanded, tiny spheres of light breaking through an ocean of shadow. Over time, these bubbles grew larger, merged with others, and slowly, a clearer cosmos began to take shape. Astronomers call this Great Awakening the epoch of reionization, the era when light reclaimed the universe from its own darkness. It was not a sudden sunrise, but a gradual unveiling. Over hundreds of millions of years, star by star, galaxy by galaxy, the fog retreated. The universe became see-through, revealing its structures, its patterns, its infinite depth. It was a quiet transformation, invisible to the eye, yet monumental in its consequence. But before that clarity came, there was struggle. The first galaxies formed in a hostile environment, surrounded by cold gas that resisted their light. Each star that burned had to fight to exist, its radiation carving through layers of hydrogen like fire through mist. Many stars lived brief lives, collapsing into black holes that would one day anchor new galaxies. Their deaths scattered heavy elements, carbon, oxygen, and iron into the void, enriching the universe for generations of stars yet unborn. The light of those first stars was fierce but fleeting. They lived only a few million years before dying in titanic explosions, supernovae that tore through the fog like lightning across a storm. These blasts not only ended lives but created new beginnings. Shockwaves compressed nearby gas, triggering more star formation, spreading light even farther. The foggy universe was slowly learning to breathe, to glow, to remember itself as something alive. In those ancient times, the sky would have been unlike anything we can imagine. There were no well-formed galaxies, no familiar constellations. Instead, the heavens shimmered faintly, as if veiled by translucent smoke. Points of brilliance flickered here and there, the birth cries of new suns. The fog absorbed much of their light, but it could not silence it completely. The universe, once quiet and dark, began to hum softly with energy. As more stars and galaxies formed, their radiation united in strength. The fog was now under siege from countless fronts. Every burst of starlight, every newborn cluster, contributed to the great clearing. Gradually, the darkness surrendered. The fog lifted not evenly, but in patches, leaving behind a mottled universe, some regions glowing clear and others still opaque. The cosmic dawn was messy, fragmented, and utterly beautiful. This transformation was not gentle. As hydrogen atoms lost their electrons to the oncoming flood of radiation, the temperature of the intergalactic medium soared. The cold quiet of the early cosmos gave way to a warmer, more dynamic environment. Structures began to evolve faster. Matter flowed more freely. The fog that once restrained light now became the stage on which it performed. It was as though the universe had finally opened its eyes and found itself illuminated. Even as the fog cleared, not all light escaped. Some regions of space remained cloaked, dense with gas and dust that absorbed radiation. These areas became nurseries for new stars, hidden pockets where creation continued in secret. Within them, matter danced to gravity's tune, collapsing, heating, igniting. Slowly, the universe filled with layers of complexity, bright galaxies, dim clouds, and dark voids, all woven together in silent balance. What we see today in the faintest, most distant galaxies are echoes of that age. Their light has traveled across billions of years, carrying the memory of that first clarity. To peer at them through a telescope is to gaze into a time when the fog had only just begun to lift. Their shapes are irregular, their colors raw, but they are beautiful in their imperfection, the first architects of cosmic order emerging from chaos. The James Webb Space Telescope and others like it now chase these ancient signals. Its golden mirrors are tuned to capture the faint, stretched light of that early era light that has traveled so long that it now hums in infrared wavelengths. Through it, astronomers hope to see the exact moment when fog gave way to fire, when darkness yielded to the first, trembling glow of a newborn cosmos. Every new observation adds another piece to the puzzle. Some galaxies appear more developed than expected, suggesting that the first structures formed earlier than we once thought. Others show signs of intense star formation, bright, chaotic, and turbulent. Together, they reveal that the universe wasted no time in building itself. Even amid fog and confusion, creation rushed forward, as if driven by a deep and irresistible impulse to shine. The clearing of the fog also changed how matter moved. Photons, once trapped, could finally travel freely, carrying energy and information across space. The universe became transparent not just to light, but to understanding. It was only then that cosmic patterns, filaments, clusters, and vast empty voids began to emerge clearly. The universe's skeleton was laid bare, its structure illuminated by the light it had fought so long to release. For billions of years since, that light has never stopped traveling. It fills the universe still, a diffuse glow known as the cosmic background. Though faint and cold now, it is a reminder of that first illumination, when fog and fire met and the cosmos awoke. Every photon we see from that time is a whisper from the dawn, a message saying, "I was there when the universe first saw itself." If one could drift through that ancient fog, the experience would be haunting. The light would not be blinding but soft, filtered, scattered by gas. Stars would appear as distant halos, their edges blurred by haze. The silence would be immense, broken only by the invisible hum of radiation. It would feel like walking through the memory of creation, a dream still half-formed, where every spark hints at awakening. In this way, the universe teaches patience. Its first light did not arrive in haste, it took hundreds of millions of years for clarity to win. Every photon that broke through the fog had to fight for passage, every galaxy had to assert its glow against resistance. Yet in time, persistence prevailed. The fog that once hid everything became the medium through which everything was born. The lifting of the cosmic fog also marked the beginning of time as we know it, not the counting of seconds, but the unfolding of visible history. Before that, the universe was hidden even from itself. With light came awareness, form, and record. Every ray became a storyteller, carrying the news of stars, gas, and gravity across unimaginable distances. It was not just illumination but revelation. And as the fog receded, color began to exist. Hydrogen burned with faint crimson hues, while newborn stars glowed blue and white. The cosmic palette expanded, filling the void with variety. It was the first moment the universe painted itself a masterpiece of light against an infinite canvas of black. The fog had not only hidden this beauty but, in dissolving, had made it possible. The echoes of that clearing still shape us. The very atoms in our bodies, forged in later generations of stars, exist because the fog once lifted. Without those early bursts of fusion and the scattering of elements they caused, there would be no planets, no life, no observers to wonder at the night sky. The fog's end was not merely the beginning of visibility, it was the prelude to existence itself. Astronomers trace the timing of this transformation by studying how distant light interacts with intervening hydrogen. Some of that gas still lingers, faint and cold, absorbing particular wavelengths. In those spectral fingerprints, scientists can read the story of the fog's retreat, when, where, and how the universe became clear. Each line of data is a sentence in the cosmic diary of awakening. In the end, the fog was not an obstacle but a womb. It nurtured the first stars, cradled the earliest galaxies, and softened their fierce beginnings. It gave the cosmos time to mature before unveiling it to the full glare of light. When it finally faded, the universe was ready, structured, luminous, alive with complexity. The fog's vanishing was not disappearance, but birth's completion. And so, the story of the fog and the first light is one of transformation, of patience rewarded by brilliance. The light that pierced it did not erase the darkness but gave it meaning. From that balance of shadow and illumination, everything we know emerged: galaxies, stars, worlds, and us. To look up at the sky now is to witness the lingering memory of that first dawn, still spreading outward, still lighting the way for those who dream beneath it. The universe, once blind, could finally see itself. The fog had lifted, and in the calm that followed, a billion suns began to whisper their stories into the deep, unending dark. When astronomers first peered back into the earliest chapters of the universe using powerful telescopes, they anticipated seeing faint smudges, fragile, newly formed galaxies, dimly lit and small. But what appeared instead startled everyone. Some of these ancient galaxies, born when the universe was less than 5% of its current age, were unexpectedly massive, already glowing with billions of stars. It was as if, in the cosmic dawn, the universe had skipped several steps of childhood and grown up too fast. These discoveries began to rewrite our understanding of how quickly galaxies could form. The earliest models suggested a slow, steady process, tiny structures merging over eons to build the larger systems we see today. Yet, the light captured from these faraway objects told a different story. Galaxies existed only a few 100 million years after the Big Bang that were too large, too bright, and too orderly to fit the old timeline. It was as though the cosmos had found a shortcut to maturity. The James Webb Space Telescope, with its exquisite sensitivity to infrared light, revealed these surprises in stunning detail. It looked farther than any human instrument had before, reaching into the universe's first billion years. What it found was a population of galaxies shining far brighter than anyone had imagined possible. Their light had traveled for over 13 billion years, yet they appeared confident, well-formed, and filled with complex structures, spirals, clusters, and glowing cores. For scientists, this presented both wonder and confusion. How could so much material have gathered so quickly after the Big Bang? The laws of physics governing gravity and star formation seemed too slow to build such giants so early. Some proposed that our models were missing key ingredients, perhaps dark matter behaved differently than expected, or star formation was far more efficient in the early universe. The mystery deepened with each new image Webb returned. The galaxies, rather than being chaotic blobs, showed organization, the beginnings of disks, even bulges resembling mature galaxies like the Milky Way. It was a revelation. If order existed that early, then the universe was assembling itself with astonishing precision. The chaotic picture of early formation was now challenged by something more deliberate, almost elegant, as if the cosmos had learned its craft faster than we ever dared assume. In the faint red glows of these ancient systems, astronomers detected signatures of heavy elements, carbon, oxygen, and nitrogen, evidence that several generations of stars had already lived and died. That meant the universe's first stars must have formed, burned, and exploded even earlier than predicted. The timeline of creation was shrinking. Everything we thought took billions of years might have happened in mere hundreds of millions. Each new observation sent ripples through cosmology. Researchers began to question the precision of their models, wondering if perhaps the universe expanded or cooled at a slightly different rate than once believed. The early cosmos, instead of being slow and cautious, seemed exuberant, a burst of creativity painting galaxies across the void in record time. The deeper the telescopes looked, the more vibrant and complex that early epoch appeared. The discoveries also hinted that dark matter, the invisible scaffold holding galaxies together, played a more active role than expected. Perhaps it clumped faster, pulling ordinary matter into dense regions where stars could ignite sooner. Or maybe exotic forms of physics governed those early centuries' interactions and energies we have yet to understand. Every answer opened new questions, like doors leading into deeper halls of mystery. Some of the galaxies Webb observed appeared so luminous that they challenged even the limits of what stars alone could explain. Their brightness suggested the presence of enormous black holes, millions or even billions of times the mass of the Sun, already in existence just a few 100 million years after the Big Bang. That was supposed to be impossible. Black holes were thought to grow slowly, feeding on surrounding gas, but these seemed to have sprung into existence almost fully formed. If these ancient giants truly housed supermassive black holes, then the seeds of those cosmic monsters must have been planted in the earliest flickers of light. Perhaps the very first stars collapsed into enormous black holes that merged and grew faster than expected. Or maybe, in the dense heart of early galaxies, gas clouds skipped the star phase altogether, collapsing directly into black holes. Whatever the cause, it meant the universe was far more dynamic and ambitious in its youth than anyone predicted. For astronomers, these findings were thrilling and humbling. Decades of theory, refined by generations of thinkers, suddenly seemed incomplete. Yet science thrives on surprise, and each unexpected discovery only deepened our curiosity. The universe was not behaving according to the script we wrote, it was improvising, and we were the captivated audience, watching in awe as it revealed its secrets line by line. These surprises also forced a rethinking of how light behaves over cosmic distances. The earliest galaxies appeared redder and brighter than anticipated, perhaps because they contained swarms of young, massive stars that burned intensely before fading. Their combined glow stretched across time, like the last embers of a distant fire. It was possible, too, that dust, that humble byproduct of stellar life and death, was already shaping the light of the infant universe. The very existence of dust that early was another shock. Dust requires heavy elements forged in stars, and yet here it was, dimming and scattering light within galaxies formed only a few 100 million years after everything began. That meant the first stars lived hard and died fast, spewing their ashes into space to seed the next generation. Even in its youth, the universe was already a cycle of death feeding life, creation woven with destruction. Each surprise changed how we view our place in the cosmos. If galaxies could grow so fast, perhaps the Milky Way's own ancestry is richer and more tangled than we know. The small systems that eventually merged to form it might have been brilliant and powerful in their own right, burning fiercely before fading into our history. The night sky above us, then, is not just a window but a time machine showing the echoes of rapid creation that made all we see possible. These discoveries remind us that the universe is not static or predictable. It evolves in bursts and pauses, in quiet eras and wild explosions of growth. What we thought was a simple, gradual story has turned out to be a complex symphony of overlapping rhythms. The early universe, once imagined as empty and slow, is now revealed as teeming with energy and motion, a child universe full of surprises. Some scientists even began to speculate that perhaps our understanding of cosmic expansion itself needs revision. If galaxies formed earlier and faster than predicted, maybe the rate at which matter clumped together was influenced by factors beyond our current models. Perhaps dark energy behaved differently then, or gravity acted in unexpected ways. The early universe may hold answers not only to how galaxies formed but to the fundamental forces shaping everything. But amid the technical debates and shifting equations, a sense of wonder remains constant. To see light that left its source more than 13 billion years ago is to glimpse the first pages of existence. Each faint glow is a relic of a time when the universe was still deciding what it wanted to be. And now, as those photons reach our telescopes, they whisper, "You still do not know me entirely." The shock of these discoveries has brought cosmology to a thrilling crossroads. Do we revise our theories, or do we accept that nature has found ways to outpace our imagination? In truth, both paths lead to growth. Every unexpected galaxy, every strange reading, expands the frontier of understanding. The universe refuses to fit neatly into our expectations, and that refusal is what keeps discovery alive. The beauty of this unfolding story is that each surprise reveals not confusion but complexity. The universe is not broken, it is richer. Its rules still hold, but they play out in ways we have yet to fully comprehend. What seemed impossible yesterday becomes fact today, and tomorrow, perhaps, will show us even more startling truths. That is the rhythm of exploration, humility before the vastness of what we do not yet grasp. Even the galaxies that defy our theories are teachers. Their light carries lessons written in wavelengths, messages that challenge us to look deeper. Some appear older than the universe should allow a paradox that forces us to reconsider measurement, time, and the fabric of reality itself. In these moments of contradiction, science does not falter, it flourishes. Every mystery is an invitation to learn anew. When scientists compare these early galaxies to modern ones, they notice echoes, similar shapes, similar densities, the same gravitational choreography at work. It's as though the universe found its patterns early and has been repeating variations of them ever since. From chaos, symmetry emerges. From randomness, rhythm. What surprises us most is not that galaxies formed quickly, but that they formed beautifully. And so, we find ourselves at a new frontier, not the edge of space, but the edge of understanding. Each revelation from the deep cosmos forces us to rewrite the story of beginnings. Yet even as we correct our theories, one truth remains unchanged: the universe is always larger, stranger, and more astonishing than we expect. Its surprises are not mistakes in our reasoning, they are reminders that creation is infinite in its imagination. In this, there is something profoundly comforting. The cosmos does not hurry to fit our explanations. It unfolds at its own pace, revealing wonders in its own time. Our role is not to master it but to listen, to watch, and to marvel as it shows us new ways of being. The surprises it gives are not setbacks but gifts, glimpses of the boundless creativity that shaped everything from the first stars to the hearts that now wonder about them. Perhaps, in the end, the biggest surprise is not how fast the universe built itself, but how deeply we feel connected to its story. We, too, are made of sudden brilliance atoms forged in the chaos of early stars, arranged into beings capable of awe. The same impatience that drove galaxies to bloom early lives within us as curiosity. And through that curiosity, the universe continues to know itself. The light from those surprising galaxies is still traveling, still arriving, still speaking. It crosses the cold and empty reaches of time just to remind us that beginnings are never as small or slow as we imagine. Every photon that strikes our detectors is a revelation. The cosmos has always been one step ahead, full of wonders far beyond our expectations and always ready to show us more. The early galaxies were not clean and polished like the ones we see in glossy telescope images today. They were messy, cluttered, and veiled in a haze of cosmic dust. This dust was born from the death of the first massive stars, ashes scattered across the newborn universe. It absorbed the pure light of young stars and re-radiated it as a softer, redder glow, painting the early cosmos in hues that seemed almost secretive, as if it wanted to hide its true nature behind a gentle, rosy fog. When astronomers peer deep into this era, they often see galaxies glowing red not because they are made of fire, but because their light has been stretched and filtered by both dust and distance. The farther we look, the more that light has traveled, and the redder it becomes. Dust, however, plays its own game, swallowing blue starlight and allowing the softer tones to escape. It's as though the early universe preferred to whisper in crimson and bronze rather than shout in blue brilliance. In those dusty clouds, stars were born at furious rates. Each collapse of gas and dust into a newborn sun released energy, stirring the surrounding space into chaotic waves. The more stars that formed, the more dust filled the air. The cycle continued, turning these young galaxies into bustling workshops of creation hidden under a dusty veil. It's hard to imagine, but behind that glow of red mist, the foundations of future worlds were already being built. The James Webb Space Telescope has revealed just how full of secrets these dusty galaxies are. What once looked like faint red smudges now appear as complex structures with clumps, spirals, and stretched arms. Their colors tell scientists about the temperature and composition of their stars. A deeper red can mean cooler dust or older stars. A faint golden tone may hint at regions thick with star-forming clouds. Each shade is a clue to how galaxies matured in their youth. Dust in space is not like the dust on our shelves, it is far more sacred. Each grain might contain carbon, silicon, iron, or oxygen, forged in the cores of dying stars. These particles drift through interstellar space, gathering in clouds that will one day give rise to new generations of stars and planets. In that sense, the dust of early galaxies was not merely debris, it was the seedbed of everything that would follow, from suns to soils to sentient beings who would look back at it and wonder. The red glow of these galaxies hides both warmth and mystery. Light that escapes their dusty walls has traveled for billions of years, and by the time it reaches our telescopes, it carries whispers of ancient chaos. Scientists decipher these whispers through infrared eyes, peeling back the haze to reveal the hidden fires within. Each pixel captured by the Webb telescope is a letter in a long-forgotten story, one the universe is only now allowing us to read. When these galaxies were young, they devoured gas rapidly, turning it into stars as if there were no tomorrow. The byproduct of that frenzy was dust, produced when the biggest stars exploded in supernovae, scattering their heavy elements across the void. With every burst, the universe became a bit murkier, but also richer, filled with the raw material for complexity. Dust, in a strange way, became both an obstacle and a gift, concealing the light while ensuring new wonders could form. Astronomers once thought that dust took billions of years to appear, but observations now tell a different story. Even in galaxies less than 1 billion years old, dust was already abundant. That means the first generations of stars lived fast and died young, sowing the seeds of the elements we see around us today. The universe wasted no time in becoming creative, it rushed headlong into building, burning, and burying light beneath crimson clouds. Imagine drifting through one of those early galaxies, enormous clouds of smoke-like dust swirling, stars being born in glittering clusters, and explosions lighting up the red haze from within. It would have been both beautiful and violent, a storm of creation cloaked in mystery. Every direction you looked, light would struggle to break through, scattering and diffusing into a warm, endless twilight. Even the silence of those galaxies was different. With so much dust, light traveled slower, dimmer, softer. The young universe must have felt thick with energy, like a dream still forming its own rules. From a distance, these galaxies looked like smudges of glowing ember, but within them, the forces of life and death were already writing the rules of chemistry, physics, and destiny. It's strange to think that the dust we curse on Earth, tiny particles that settle on our books and screens, shares its lineage with those ancient cosmic grains. The very same materials floating in the early universe would someday become parts of planets, plants, and people. When we wipe dust away, we are brushing off the residue of stars that lived and died before Earth even existed. The red color of those galaxies is also a kind of illusion born from the universe's expansion. As light travels through expanding space, its wavelength stretches, turning from blue to red. So, when astronomers see a deep crimson hue, they are not just seeing dust, they are witnessing time itself stretching light into longer, softer notes. It's like hearing a cosmic symphony slow down as it drifts across eternity. The secrets these galaxies keep are not just in their color or dust, but in their unexpected maturity. Some appear too massive, too organized, for how early they existed. The Webb telescope has found galaxies that seem older than the universe should have allowed at that stage. That discovery has puzzled scientists. Were we missing something about how fast galaxies grew? Or were the early conditions more fertile than we imagined? The dust complicates the picture. It hides some stars and reveals others. It can make a galaxy appear older or younger, depending on how it's distributed. In a way, dust is the universe's way of keeping some stories half-told, inviting us to look deeper. Every new observation reveals another layer beneath the haze, like finding lost pages of a cosmic diary written in light and silence. Yet even through the fog, there's warmth. The same dust that hides starlight also holds heat, re-radiating it gently. This warmth could be felt in the infrared, a glow like embers left after a cosmic fire. That glow still lingers today, stretched thin but persistent, as if the universe has never stopped humming softly in the dark. Each grain of cosmic dust is a memory of a star that lived, of a burst that scattered elements into the void. Together, they form the tapestry of all future creation. Without dust, no planets could exist, no oceans could form, and no eyes could ever rise to witness the stars. The secrets hidden in that redness are not just about galaxies, they are about us. In the stillness of deep space, those early galaxies remain suspended in time, their dusty halos glowing faintly in the endless dark. As we study them, we are not just looking back in time, we are looking at the universe's private workshop, its hidden place of alchemy, where simple hydrogen first learned how to make something more. It's humbling to think that the universe's first whispers of complexity were not clean or clear, they were murky, red, and hidden. But maybe that's how all creation begins, in dust and secrecy, before light learns how to sing freely. The more we learn, the more we realize that the early cosmos was not empty or sterile, but alive with transformation and potential. Every time a telescope catches the faint glow of one of these dusty galaxies, it captures a heartbeat from the universe's childhood. That light traveled for billions of years, through expanding space and cold voids, to reach us. And when it finally does, it tells a story not of chaos, but of patient creation, of beauty hidden behind veils, waiting to be seen. Somewhere in that red haze, we can almost feel the pulse of the beginning, gentle, persistent, and full of promise. The dust that once dimmed the stars has become our greatest teacher, showing us that even the universe's imperfections can be beautiful beyond measure. And perhaps, in that soft glow, we can sense a reflection of ourselves, creatures of dust and light, trying to remember where we came from. At the hearts of the earliest galaxies, hidden behind clouds of gas and dust, slept something unimaginably dense and hungry. These were the first black holes, tiny compared to the monsters we see in galaxies today, yet powerful beyond measure. Born from the collapse of the universe's first massive stars, they were seeds of darkness, weighing only a few hundred to a few thousand times the mass of the Sun. But they had one great advantage: time. And in time, they would grow. These small black holes did not sit quietly. They fed on the gas swirling around them, swallowing matter and light in violent bursts. Every time they consumed, they released energy, powerful radiation that blazed from their surroundings even as their centers remained invisible. It was as if the universe had built engines of gravity so intense they could light up the darkness simply by falling inward. The early galaxies were small, chaotic, and full of collisions, and within that chaos, the black holes found nourishment. When two galaxies merged, their central black holes often drifted toward one another, eventually dancing and fusing into something larger. Each merger meant more gravity, more heat, and more opportunity for light to erupt from the edges of darkness. Astronomers call these early, glowing black holes quasars. Even though the black holes themselves were tiny, the energy released from their surroundings was staggering. Gas spiraled inward, heated by friction to millions of degrees, and burst out as brilliant jets that could outshine entire galaxies. These young quasars were like cosmic lighthouses, signs of both destruction and creation in the same breath. But their existence so early in the universe shocked scientists. Some black holes in young galaxies appear to have reached millions, even billions of solar masses within a few 100 million years. That seemed impossible, given how slowly black holes were expected to grow. So the question arose, were these tiny black holes really small to begin with? Or had something extraordinary helped them grow so fast? One theory suggests that some black holes skipped the small stage entirely. Instead of forming from dying stars, they might have been born directly from collapsing clouds of primordial gas, a shortcut that let them start off already massive. These direct collapse black holes could explain how some galaxies developed such powerful centers so early, feeding on streams of matter from their surroundings like cosmic infants with endless appetites. No matter how they began, these early black holes played a crucial role in shaping their galaxies. As they fed, they released jets of energy that pushed gas away, slowing the formation of new stars. In this way, black holes acted as both creators and regulators, helping galaxies grow, but never too fast. Their gravity held galaxies together, while their fury kept them from collapsing under their own ambition. In the soft, dim light of the early cosmos, these centers would have glowed like lanterns wrapped in mist. The surrounding dust re-radiated the heat, turning violent radiation into warm, red light. To the eye of a distant observer, such a galaxy would appear calm and lovely, but inside, its heart was a storm of gravity and flame, churning endlessly. When telescopes like Webb look deep into the early universe, they can sometimes detect signs of these hidden hearts. The faint flicker of X-rays, or the unusual brightness in a small region, reveals where a black hole might be feeding. Yet the images are still hazy, still wrapped in uncertainty. We are peering at monsters in their infancy, far too distant to see clearly, but close enough to know they were already awake. Some of the smallest galaxies we've found, barely a fraction of the Milky Way's size, already host black holes in their centers. This tells us that the bond between galaxies and their black holes began early, perhaps from the very beginning. The two grew together, guiding one another like dance partners in a cosmic waltz. Without one, the other could not have become what it is. The idea that even the tiniest galaxies carried black holes inside them changes how we think about cosmic evolution. It means that black holes were not rare intruders, but natural parts of galaxy life. They were there from the start, influencing the shape, brightness, and rhythm of the young universe. They were, in a sense, the hidden architects of structure itself. Though we often imagine black holes as destroyers, in those early days, they were also sculptors. Their immense gravity gathered gas toward the center, making galaxies more compact and organized. And their bursts of energy carved out channels in the surrounding matter, allowing new stars to form in the right places. Chaos gave birth to order, guided by invisible hands of gravity. It's fascinating to imagine what it would have looked like up close if one could drift safely near such a galaxy. The center would shimmer with hot, glowing gas orbiting the black hole, like a ring of fire. Beyond that, stars and dust would swirl in patterns carved by unseen gravity. The black hole itself would be invisible, yet everything around it would move to its rhythm, like instruments following a silent conductor. Even now, as we look at distant galaxies that existed billions of years ago, we can sense those rhythms. The mass of a black hole often matches the mass of the galaxy's central bulge, as if they've grown in lockstep. It's a strange relationship, how something so small compared to an entire galaxy can govern its structure and soul. But the universe seems to insist on this balance, a harmony written into its laws. When we find the earliest black holes, we also find the earliest galaxies beginning to mature. These tiny centers might have ignited the first quasars, whose light pierced the cosmic fog and helped re-ionize the universe. In a way, Black holes may have helped end the cosmic dark ages by lighting the path forward with their furious glow. Their growth, however, remains a mystery. How did they eat so fast? How did they avoid running out of gas in a young, crowded universe? Scientists suspect that streams of cold gas, funneled through cosmic filaments, fed them directly. These invisible rivers connected galaxies like veins, delivering nourishment straight to their hungry cores. Every black hole, no matter how small, changes the fabric of space around it. In those early times, countless such distortions must have rippled through the young cosmos, bending light and time in tiny waves. The echoes of those distortions, gravitational waves, still travel through space today, silent reminders of the universe's restless youth. The story of these small, mighty centers is a story of contrast. They were tiny points of infinity surrounded by vast clouds of creation. They devoured matter, yet gave rise to light. They seemed to destroy, yet they made structure possible. In their paradox, we glimpse something essential about the universe itself, that creation often comes from collapse, and brilliance from shadow. Even as we study them with modern instruments, we can never truly see a black hole. We only see the light it affects, the gas it twists, the stars it pulls. It remains the ultimate secret, perfectly silent, perfectly dark. And yet, its influence fills the universe like the sound of a drum we cannot hear but can feel in every vibration of space. Some of the earliest black holes may still exist today, hidden deep within dwarf galaxies or floating alone in the intergalactic void. They are relics of a time when the universe was young and fierce, carrying memories of an age when gravity was still learning how to shape beauty out of chaos. To find them is to find fossils not of stars, but of gravity itself. If we could gather all those early black holes and listen closely, perhaps the universe's early heartbeat would emerge a slow, steady pulse of collapse and light. Every flicker, every eruption, would mark a step toward the galaxies we now see. Every small, mighty center would be a spark of structure in a sea of darkness. When we look at the vastness of today's galaxies, the majestic spirals, the glowing cores, we are seeing echoes of that long process. The seeds planted by tiny black holes have grown into the great centers we now observe, each one still whispering the same quiet truth, that even the smallest point of darkness can become the source of unimaginable light. The early universe may have been loud with collisions and chaos, but in its deepest places, silence ruled. And in that silence, black holes formed the quiet kings of creation, waiting for the universe to grow around them. They were small, but they were mighty, and from their hunger came the architecture of everything we know. Now, when we look back billions of years through telescopes, we are not just watching galaxies form, we are watching the rise of gravity's first great storytellers. The black holes that began small and unseen have written the tale of cosmic evolution in light, in dust, and in time itself. And their story is far from over. In the beginning, everything was movement. Gas clouds collided, stars erupted into being, and galaxies spun themselves from the debris of creation. The early universe was not peaceful, it was restless, young, and full of energy that refused to settle. But over time, as if taking a deep cosmic breath, the chaos began to slow. Gravity, that quiet sculptor, started shaping the disorder into something steady, something calm. Each galaxy carried within it the memory of turbulence. Clouds of hydrogen and helium swirled under invisible forces, sometimes colliding with others in dazzling violence. But as billions of years passed, the frantic collisions became rare. Stars aged, dust settled, and the frenzied birth cries of the cosmos softened into a whisper. The universe began to trade its fiery youth for something more serene, a vast and measured expansion, like a tide moving steadily outward. The galaxies that once looked like shattered fragments began to find their form. Some became spirals, smooth and balanced, their arms unfolding like cosmic petals. Others became ellipticals, round and quiet, filled with old stars glowing gently in their retirement. The energy that once tore matter apart now held it together. It was as if the universe, after eons of trial and error, had finally learned the rhythm of its own heartbeat. This transformation wasn't sudden, it was gradual, patient, and persistent. Gas cooled, slowing the birth of new stars. Explosions from supernovae cleared the skies, pushing away leftover chaos. And deep in the hearts of galaxies, black holes that once roared with energy began to rest. The universe that once screamed with radiation began to hum in balance. Creation was no longer a storm, it was a song played in time. If we could watch the unfolding from afar, we'd see that calm spreading like a dawn. The wild brightness of youth dimmed, replaced by softer tones of red and gold. The fiery nurseries of stars gave way to long stretches of quiet dust, drifting peacefully between mature suns. Even the background light of the universe cooled, its once fierce blaze stretched thin into a gentle microwave glow that still bathes us today. The same forces that had caused chaos also built stability. Gravity, the universal glue, continued to weave its invisible web. It linked galaxies into clusters and clusters into vast filaments. The fabric of the cosmos, once wrinkled by explosions and collapse, began to smooth out. In that grand tapestry, emptiness itself became more structured, quiet but ordered, immense yet stable. The early storms of radiation faded as the first massive stars burned out. The light that once dominated the skies grew dimmer, softer. Now, galaxies illuminated the darkness like islands of serenity in a vast sea. What was once chaos had become a cosmic equilibrium, where balance replaced fury and time moved in long, deliberate strides. The galaxies themselves aged gracefully. The gas that once formed stars became scarce, leaving fewer opportunities for birth and fewer chances for disruption. With less turmoil, the stars could live long and predictable lives, tracing slow arcs through space. The frantic collisions that once defined galactic youth became rare events, whispers instead of roars. Some might say the universe grew tired, but it would be more accurate to say it grew wise. Energy no longer scattered wildly but circulated in patterns. Galaxies rotated with elegance, like dancers who had practiced for eons. The once violent interactions of matter became the quiet motion of balance, as though the cosmos had found its own inner peace. Yet beneath this calm, faint echoes of the old chaos still lingered. Supernovae continued to flash in distant corners, black holes still devoured what came too close, and new stars were born from leftover clouds. But these were exceptions, not the rule. The universe had settled into Middle Age, where creation and destruction existed in harmony instead of constant battle. The slowing of chaos was not the end, it was transformation. Like a fire that cools into embers, the universe still glowed, but now with patience. The energy was not gone, it was simply spread wider, shared among the stars. Where once everything fought to exist, now everything coexisted, each part aware of the others through the quiet tug of gravity. Astronomers studying these calm galaxies can still see the ghosts of their pasts. Some spirals bear scars, twisted arms, uneven edges, remnants of old collisions. Others hold faint halos of stars, drifted out over time. These marks are reminders that peace was earned, not given. The calm we see now was carved from struggle and change, from the universe's endless capacity to evolve. The stars that were once hot and young have now cooled into deeper colors. Blue giants have faded, leaving behind red dwarfs and ancient suns. The light that fills the cosmos is no longer sharp or blinding, it's warm and steady, like a lantern left to burn through the night. Time has turned brightness into endurance, fire into glow. Even the black holes, those furious eaters of matter, began to rest. With less fuel to consume, their roaring accretion disks faded into silence. They remained, powerful but quiet, like mountains standing in the dark. Their gravity still ruled the hearts of galaxies, but they no longer shouted their presence through violent radiation. They had become still monarchs of calm kingdoms. In this era, new elements forged in ancient stars began to drift together, forming the raw materials of future planets. Iron, carbon, and oxygen mixed in the cooled dust, creating the foundations for complexity. From the universe's calm came the possibility of life, as stability allowed for subtlety, and silence allowed for structure. Each pause in creation allowed something new to arise. Where once explosions dominated, now chemistry began to whisper. Molecules could form and survive, protected by the quiet. The calm of the universe gave matter time to think, to combine, to grow, to evolve into things that could one day observe their own beginnings. It's humbling to realize that life, in all its delicacy, could only appear once the universe learned to rest. Chaos made stars, but calm made consciousness. The same stillness that now fills the space between galaxies also fills our nights with peace, the same dark silence that nurtured atoms into awareness. When we look at the universe now, we are seeing the aftermath of that great unwinding. The galaxies drift farther apart, their interactions fewer and gentler. The light that reaches us is ancient, the product of billions of years of slowing and cooling. The cosmos, once a storm, has become an ocean of quiet light, wide, deep, and endlessly patient. This calm is not the absence of energy, but its perfection. Every star, every orbit, every drifting photon exists in balance with the rest. It is the grand pause between movements in a cosmic symphony, where the music of expansion softens before the next crescendo. The universe is breathing slowly now, and in that breath, everything finds its place. If chaos was the universe's childhood, then this calm is its adulthood. It carries the memory of its wild youth but moves now with intention. Stars still form, but they do so with grace. Galaxies still evolve, but not in haste. The rhythm of time has slowed to something almost human, something that speaks of patience, of reflection, of endurance. In that patience, beauty has deepened. The bright explosions have given way to delicate details, faint rings of light, wisps of dust, ancient clusters of stars glowing like embers in the night. The universe has not lost its vitality, it has refined it, distilling chaos into serenity, noise into harmony. Even as expansion continues, the calm holds. Space stretches, but the great structures remain steady. Clusters of galaxies drift apart but stay bound within their own local networks. The cosmic web remains intact, an intricate lace of gravity and light. The slow unwinding has not unraveled creation, it has made it graceful. The background radiation, once deafening, has cooled into a soft murmur. That faint glow, the cosmic microwave background, is the universe's lullaby, a reminder of its fiery birth now tempered by time. It fills every corner of existence, invisible yet constant, a hum that keeps the memory of chaos alive in a world that has learned tranquility. If one could float through the cosmos today, there would be silence, no wind, no echo, just the faint radiation of old light and the steady pulse of distant galaxies. Each point of brightness would represent the universe's victory over chaos, its ability to turn disorder into rhythm, fire into form, beginning into being. This great unwinding is still happening. The universe continues to expand, to stretch and cool. Someday, billions of years from now, even the calm may fade into something deeper, a silence beyond imagination. But for now, it rests in perfect balance, a long exhale after a storm. And perhaps that is the greatest story the cosmos tells, that peace is not the opposite of chaos, but its evolution. From the wildness of creation came harmony, from the noise came the whisper, and from the blazing fire came the gentle, steady light that fills our night skies. The universe, once frantic, now drifts in quiet majesty, carrying the memory of motion within the stillness of eternity. The universe was never meant to be neat. Its beginnings were wild, its growth unpredictable, and its beauty imperfect. Yet in that very disorder lay the instructions for creation. The messiness of the cosmos, the uneven scatter of gas, the chaotic collisions, the asymmetrical galaxies, was not a flaw but a form of learning. It was how nature experimented, made mistakes, and discovered balance. Without that early chaos, there would be no structure, no stars, no life to contemplate it. In those first ages, nothing obeyed a tidy plan. Clouds of gas clumped unevenly, collapsing in some regions while others stayed empty. Some stars lived fast and exploded, while others lingered quietly. This imbalance created contrast, and from contrast came evolution. The messy distribution of matter shaped gravity's hand, allowing galaxies to form in the places where randomness gathered most tightly. In its confusion, the universe was actually sculpting purpose. If everything had been perfect and even, nothing would have happened. Smoothness is beautiful but sterile, it leaves no reason for motion. The universe needed flaws, tiny quantum ripples in the early fabric of spacetime, to create the seeds of galaxies. Those small irregularities, magnified by gravity over billions of years, gave birth to every structure we now see. Perfection would have meant silence, Messiness meant music. As galaxies collided, stars were ripped apart, and new ones were born from the debris. Each messy interaction spread heavy elements, enriching the cosmos with the ingredients for planets and people. If galaxies had stayed separate and still, the chemistry of life would have remained locked in stars. It took turmoil, gravitational chaos, and cosmic accidents to mix everything together. Creation needed collisions to grow complex. Even within galaxies, messiness ruled. Stars didn't form evenly, they came in clusters, with some regions bursting with new light while others slept in darkness. Dust clouds swirled and tangled, creating unpredictable beauty. And out of this uneven pattern came diversity, different kinds of stars, planets, and systems. The universe learned through variation, not through symmetry. Astronomers have come to realize that the universe's rough edges are not mistakes but milestones. Every explosion, every uneven shadow in a nebula, every warped spiral is evidence of change. Nature doesn't erase its errors, it builds on them. The asymmetry of galaxies is not chaos out of control, but a reminder that creation is always in progress, always unfinished, always curious. The universe teaches that growth is rarely elegant at first. The earliest galaxies were clumpy, irregular, and small, yet from them evolved the graceful spirals we now see. Their uneven beginnings gave them resilience, the ability to adapt, merge, and survive. Each messy step was necessary, a trial run for the harmony that would come later. From disorder rose design, though the universe never planned it that way. Even the stars themselves carry the lesson of imperfection. Their births are turbulent, their lives full of instability. They flicker, pulse, and shed layers of gas in unpredictable ways. Yet through all that, they create balance, fusing atoms with precision so fine that even the smallest change would alter the outcome. The stars' calm appearance hides storms, and those storms are what make them shine. On Earth, we inherit that same principle. Life, born from cosmic debris, thrives on messiness. Evolution itself is a process of trial and error, of mutation and correction. The random mistakes in DNA are what allow species to adapt and survive. The same forces that shaped galaxies also shaped us: curiosity through chaos, progress through imperfection. The mess is the method. If the universe could speak, it might tell us that order is not the absence of mess, but the understanding of it. The grand patterns of galaxies only exist because of the smaller, random motions of matter within them. Like the strokes of a painting that seem chaotic up close but beautiful from afar, the universe's messiness resolves into meaning only when viewed on the largest scales. Astronomers often marvel at how galaxies evolve after collisions. Two disordered, shattered systems merge into one, first violently, then gracefully. Stars are thrown around, gas clouds compressed, and new bursts of life ignite. From wreckage comes renewal. The universe doesn't fear destruction, it uses it. That's the ultimate lesson in its mess: even loss has purpose. The same is true for the stars that die in explosions. When a massive star collapses, it scatters elements into space: iron for blood, carbon for life, oxygen for breath. The death is chaotic, yet it sows the seeds for everything that follows. Messiness, again, is creation's greatest ally. The universe writes its future in the ashes of its own mistakes. Scientists used to think that galaxies should be clean and symmetrical to be stable. But the more we look, the more we find irregularities everywhere: streams of stars pulled from ancient mergers, uneven dust lanes, twisted arms. And yet these galaxies thrive. It seems that the universe prefers a kind of graceful imperfection, a stability that grows from movement, not stillness. The deeper we study the cosmos, the clearer it becomes that disorder is not random, it's rich with hidden structure. Fractal patterns appear in everything from the clustering of galaxies to the turbulence of interstellar gas. The universe doesn't repeat itself exactly, but it echoes, shaping chaos into harmony at every scale. If the cosmos were a teacher, it would never give perfect answers. Instead, it would hand us puzzles, messy, incomplete, open to interpretation. Each time astronomers think they've found simplicity, new data reveals complexity underneath. That's how knowledge expands, through the humbling realization that the universe refuses to fit neatly into our expectations. Even time itself moves unevenly. Galaxies evolve at different rates, stars age unpredictably, and black holes distort the very flow of moments. This unevenness makes the cosmos dynamic, it prevents stagnation. The universe's refusal to march in perfect rhythm is what allows it to surprise us, to stay alive in its own quiet way. Messiness also gives room for creativity. In the collisions of galaxies, new patterns emerge: rings, spirals, arcs of glowing gas. Each event is unique, like fingerprints on the face of the cosmos. Nothing repeats exactly, and that variety is its beauty. It's proof that imperfection is not failure, it's individuality written in starlight. There is also a deep comfort in knowing that even the universe was awkward once. The galaxies we now see as majestic spirals were once uneven blobs of dust. Their elegance came only after billions of years of trial, collision, and correction. Perfection is never immediate, it is the shadow that chaos leaves behind after learning to calm itself. When we gaze at those faraway galaxies, we're looking not just at what they became, but at what they overcame. Every curve, every swirl of dust, every tilt in their arms tells a story of resistance, how disorder found direction. The universe's lesson is clear: progress isn't about eliminating chaos, but about learning to dance with it. That's what makes cosmic messiness such a profound teacher. It reveals that beauty and balance come from persistence, not precision. Galaxies didn't stop forming when they collided, they evolved because of it. The same is true for everything that grows. Even in our lives, the moments of confusion, the mistakes, the imbalance, those are the furnaces where meaning is made. The universe also reminds us that chaos is temporary. It serves a purpose, shaping new paths, then fading as stability forms. What was once wild becomes gentle, what was once unstable becomes enduring. The great unwinding of the cosmos is full of these transitions, each messy beginning resolving into calm. And just when peace seems permanent, new chaos begins the next cycle. Through this eternal rhythm, the cosmos teaches patience. Every dust cloud, every starburst, every collapse takes time, millions or billions of years. Nothing perfects itself quickly. The mess must exist first, long enough for patterns to emerge. If we could compress cosmic history into a single day, most of that day would be spent in chaos, and only at the end would beauty begin to show. There's a quiet honesty in that idea. The universe doesn't rush. It accepts its flaws and lets them become foundations. It doesn't hide the mess, it uses it. From a distance, the night sky looks orderly, filled with constellations. But behind that illusion lies endless disorder, stars at different depths, galaxies twisting, dark matter shaping everything unseen. And still, it's breathtaking. Even the smallest irregularities, tiny temperature fluctuations in the cosmic microwave background, are proof that imperfection built everything. Those minute ripples, born fractions of a second after the Big Bang, determined where galaxies would form. Without them, there would be no stars, no worlds, no observers. The universe's earliest mess is the reason we exist. Perhaps that is why scientists and dreamers alike are drawn to the cosmos. It mirrors our own lives. Just as galaxies grow through collision, we grow through conflict and confusion. Just as stars are born from collapsing clouds, our brightest moments often rise from our darkest ones. The universe shows us that messiness is not something to fear, it's something to trust. In the end, perfection is not the goal. The universe's story is one of continuous refinement, not final completion. Every new galaxy, every dying star, every burst of light adds to a masterpiece that's never finished. Its beauty lies not in its symmetry but in its becoming. The cosmos is still learning, still unfolding, still messy, and that's why it's alive. So when we look up at the sky and see its uneven brilliance, we are witnessing the art of imperfection perfected. Each star, each ripple, each distant galaxy tells us the same thing, that messiness is not failure but creation's most sacred tool. The universe's rough edges are not mistakes, they're reminders that even in the deepest chaos, something beautiful is always trying to emerge. The James Webb Space Telescope was not built merely to look deeper, but to listen more softly to the whispers of ancient light. Where Hubble saw with the eyes of visible and ultraviolet light, Webb was given the ears of infrared, a sense tuned to warmth, to the slow glow of distant and fading heat. Through that new sense, it could pierce the veils of cosmic dust that had hidden the universe's first stars from all previous eyes. It was as if, after centuries of silence, the cosmos began to hum again. Infrared light is old light, stretched and softened by time. As the universe expanded, the once blazing light of newborn galaxies cooled into deep, reddish warmth, invisible to ordinary eyes. Webb was built to find it, to trace the gentle warmth of creation itself. Where Hubble saw shapes and brightness, Webb sees history unfolding as temperature, motion, and faint texture. It reads the ancient heat maps of the universe, uncovering where the first galaxies once burned. Each mirror on Webb gleams like a fragment of time's memory. Its golden hexagons gather whispers from the dark, focusing them with such precision that light from the first billion years after the Big Bang can be seen in astonishing detail. This light, which has traveled for more than 13 billion years, arrives fragile and stretched thin. Yet Webb, patient and sensitive, can cradle it without letting it vanish. The telescope's instruments NIR-CAM, NIR-SPEC, MIRI, and others are more than cameras, they are translators of the invisible. They take the heat from stars too distant to see and turn it into colors our eyes can understand. They uncover galaxies so red-shifted that their visible light has been transformed into warmth alone. Webb, in essence, transforms silence into melody, revealing what Hubble could only hint at. One of Webb's most profound gifts is its ability to look through dust. The early universe was not clear like glass, it was murky, full of gas and particles that absorbed visible light. Hubble's vision, though powerful, could not penetrate those clouds. But Webb, with its infrared eyes, sees through them as though lifting a cosmic curtain. It peers into star nurseries hidden within nebulae, uncovering the soft glow of stars still in their infancy. In regions where Hubble saw only darkness, Webb reveals color and motion, newborn suns surrounded by swirling disks of dust. It sees planetary systems in the making, capturing the faint warmth of dust grains as they clump together to form worlds. This warmth, once dismissed as background noise, becomes a map of creation under Webb's gaze. Each image from Webb feels alive, almost breathing. The Carina Nebula, for instance, once a faint blur, now appears like a living landscape of cliffs and valleys carved from light and gas. Webb's instruments turn that radiance into a topography of formation, every wisp of gas a trace of gravity's gentle pull. The telescope does not just see stars, it witnesses their birth pains in real time. Hubble showed us beauty, Webb shows us process. Its infrared view reveals what happens behind the scenes, the hidden machinery of the cosmos. When a galaxy forms, Webb sees its faint spiral bones still taking shape. When a star dies, Webb sees the hot remnants expanding outward, glowing like fading embers. In this warmth lies the entire rhythm of cosmic transformation. To achieve this, Webb had to live far from Earth's glow. It orbits at the second Lagrange point, a quiet pocket of gravitational balance a million miles away. There, shielded by its vast golden sunshade, it stays cold, so cold that even the warmth of a human hand could overwhelm its detectors. It listens not with sound, but with stillness, its instruments chilled to near absolute zero to feel the faintest thermal whispers. This extreme sensitivity allows Webb to detect the heat from exoplanet atmospheres, worlds orbiting distant stars. It can measure how light changes as it passes through alien skies, revealing the fingerprints of molecules, water, carbon dioxide, methane. Where Hubble glimpsed distant planets as tiny dots, Webb can now study their climates, their potential for life, their subtle warmth against the darkness. When scientists first received Webb's data, it was overwhelming. The universe looked older, brighter, and busier than anyone expected. Galaxies appeared in Webb's first deep-field images that seemed too massive, too organized for their age. It was as if Webb had stepped into a room thought to be empty and found it already full of life. The early universe, once imagined as sparse and slow, turned out to be vibrant and fast-paced. This revelation forced cosmologists to reconsider their timelines. If galaxies formed so early, then star formation must have begun sooner, and black holes must have grown faster. Webb's warmth had revealed not just hidden light, but hidden history. The quiet stretches between the first atoms and the first galaxies were shorter than we thought. In many ways, Webb sees time differently. Because light takes so long to travel, its infrared view is also a form of archaeology, digging through layers of cosmic memory. Each wavelength reveals a different era. The near-infrared shows galaxies a few billion years old, while the mid-infrared touches the faint embers of the first generation. Webb doesn't just observe, it excavates. What makes Webb's discoveries so emotional is how they feel both intimate and immense. When it observes a galaxy billions of light-years away, the light it captures began its journey before Earth even existed. Yet that same light now touches our instruments, our eyes, our understanding. The distance collapses into connection, and the warmth of creation brushes against human curiosity. The telescope's precision also lies in its teamwork. NIRCam captures images, NIRSpec analyzes their spectra, and MIRI peers into even longer wavelengths of heat. Together, they paint a full picture of each target, color, temperature, motion, composition. It's as though Webb has multiple senses working in harmony, each instrument filling in what the others cannot. Hubble's images once stunned the world with their clarity, but Webb's vision adds depth, seeing not just what something looks like, but what it's made of. Dust becomes chemistry. Glow becomes temperature. A red smudge becomes a cradle of stars. The universe stops being distant art and starts being living matter, unfolding before us. Webb's tools are so refined that even the faintest variations in heat can reveal unseen forces. Slight differences in brightness can indicate gravitational lensing, where massive clusters bend the light of background galaxies. Through these distortions, Webb glimpses galaxies even further away, their light magnified by cosmic gravity itself. Each curve of brightness becomes a telescope within a telescope. Where Hubble once stopped at silence, Webb continues into warmth. It listens to what light has become after billions of years of travel. Its sensors feel the breath of ancient suns, the soft glow of gas long cooled. In those signals, it deciphers the stories of time, how matter learned to shine, how space began to organize, how darkness itself carried creation forward. Even the way Webb sends data home is poetic. Each pixel of light, captured for hours or days, travels across the void to Earth, where it is decoded and assembled into images. Those images, filled with reds, golds, and deep blues, are not photographs but translations of energy into sight. Every frame is both science and art, the warmth of the beginning turned into a visible language. As scientists process these images, they often describe an almost spiritual feeling. Webb's infrared view gives form to what was once invisible, turning emptiness into abundance. It's as if the telescope is whispering, "There was never silence here. You just didn't know how to listen." And now, the world listens differently. Each Webb image becomes an event, a cosmic diary page written in light. Astronomers pore over spectra, tracing the lines of elements, reading the temperature signatures of early stars. Every discovery adds a sentence to the long story of existence. But Webb's power also brings humility. The more it reveals, the more mysteries it uncovers. Some galaxies appear too red, too mature, as though they formed in defiance of time. Some exoplanets show chemical imbalances that challenge our models. Webb has not simply answered questions, it has reshaped them. The silence Hubble faced was not emptiness, but unread complexity. Infrared astronomy is, in many ways, the study of ghosts, the lingering heat of things long gone. Webb captures that warmth, giving presence to what no longer exists. The first stars it studies are dead, their light stretched and weakened. Yet through Webb, their final warmth becomes eternal. It's a resurrection of light across time. The telescope's golden mirrors are not just reflectors, they're storytellers. Each one bends space's soft whispers toward clarity, turning invisible heat into patterns we can see. That transformation, from silence to warmth to image, is one of the most human acts imaginable, the act of listening, interpreting, and sharing wonder. Even the engineering behind Webb reflects this cosmic theme. Its instruments, so delicate they could tear from a whisper of heat, operate in harmony at chilling precision. The observatory's sunshield protects it from the very star that gave us life, so it can study others without interference. To see warmth, Webb must remain cold, a paradox that defines its genius. The telescope's achievements are also emotional victories. Decades of delay, technical challenges, and doubt preceded its launch. Many wondered if it would even unfold properly in space. Yet when it did, each mirror aligning, each instrument calibrating, the world held its breath. The first image, a deep field filled with galaxies, proved that patience could resurrect the unseen. Since then, Webb has continued to show us that warmth is not weakness, it's the memory of creation. The universe's earliest light may have faded from sight, but it still glows in infrared, still telling stories to those who know how to listen. Webb, patient and golden, listens better than any eye before it. When the telescope stares into deep time, it sees not darkness, but persistence. Light that refused to die, warmth that carried through expansion and decay, messages sent across eons. It reminds us that nothing truly vanishes, it only changes form. The silence Hubble once saw was never silence at all, it was warmth waiting for the right listener. And now that listener drifts quietly, a million miles away, catching the universe's oldest sighs and turning them into radiant images. Webb is not just a telescope, it's a time machine, a translator, a poet of the invisible. It shows us that even in silence, the cosmos is still speaking, and that in every faint shimmer of warmth, the story of everything continues to unfold. The universe is a melody too vast for any single note to capture, and astronomers, like patient musicians, must learn to tune their instruments to match its shifting tone. When the James Webb Space Telescope began to reveal galaxies brighter and older than expected, it was as if the cosmic song had changed key. The models that once hummed in harmony with Hubble's discoveries suddenly felt slightly off, their assumptions stretched thin by a new, more complex rhythm. Scientists had to listen closely again. Cosmology, at its heart, is about resonance, the delicate balance between theory and observation. When one shifts, the other must respond. The universe does not always play by the rules we imagine, but that is its gift. It teaches us to refine, to retune, to become better listeners. Each new observation Webb offers is a note that slightly bends the melody, reminding us that the cosmos is still composing itself as we watch. The early data showed galaxies forming much faster than expected, some with masses rivaling the Milky Way when the universe was less than 1 billion years old. The old models predicted a slower crescendo, a gentle build-up of structure. But Webb's revelations sounded like a sudden swell, a full orchestra where we expected only a single instrument. The universe had been busy long before we thought it could be. Scientists compared their models to a piece of music played in a strange tuning, recognizable, but not quite right. So they began to make small adjustments. Maybe the first stars were more efficient at forming heavy elements. Maybe dark matter clumped differently than simulations suggested. Maybe the cosmic expansion stretched light in subtle ways that affected how we measured age. Each hypothesis was a new string, tightened or loosened to bring the melody back into harmony. This process of revision is not failure, it's how science breathes. Every new telescope, every fresh layer of data, is like hearing a familiar song on better speakers. Suddenly you notice notes you'd missed before, faint harmonics that demand explanation. Webb's sensitivity has given cosmologists that richer soundscape, a universe alive with complexity, demanding finer tuning to match its truth. The models we use to describe galaxy formation depend on countless intertwined variables: dark matter density, gas cooling rates, star formation efficiency, feedback from black holes. Adjusting one changes all the others, like tightening one string of a harp alters the vibration of its neighbors. Finding the balance takes patience, and the reward is a clearer resonance between theory and observation. For decades, cosmologists had been confident in a broad picture. Small fluctuations in the early universe grew into galaxies under the pull of dark matter, stars formed slowly, and structure emerged step by step. Webb's images didn't break that picture, they simply revealed it was more intricate than we imagined, like discovering hidden harmonies behind a simple tune. The music was not wrong, just richer. Some of the earliest galaxies Webb observed appeared too bright, filled with stars that should not have existed yet. Were these galaxies really massive, or were their light properties tricking our instruments? Scientists debated, tested, and adjusted models to account for the new tempo. It turned out that some galaxies might have unusually hot, young stars, their brilliance magnified by gravitational lensing. Others may indeed be earlier giants. The score was still being written. Adjusting these models is like tuning in the dark. You listen, you feel, you wait for the vibration to align. The cosmic data doesn't give all answers at once, it hums softly, revealing its notes one by one. Webb's instruments record light curves, spectral lines, and redshifts, and from these, astronomers reconstruct how ancient gas clouds once pulsed with the first bursts of starlight. Each line of data is a measure in the universe's unfinished symphony. To match that rhythm, computers run simulations of cosmic history, evolving galaxies from simple equations of physics. They generate billions of virtual years, then compare the results to what Webb sees. When the two diverge, the tuning begins. Parameters are shifted slightly, like adjusting the tension on a cello string. Too tight, and the simulation produces too many stars; too loose, and galaxies fade before they should. The sweet spot reveals truth. The wonder of this process is how alive it feels. Theories are not static, they breathe with each discovery. When Hubble first observed distant galaxies, cosmologists reworked equations to include dark energy. Now, with Webb's deeper insight, they tweak the earliest chapters of cosmic evolution. Science moves like music does, not through perfection, but through adaptation, guided by listening. One key adjustment involves understanding how gas cooled in the early universe. Stars form only when clouds of hydrogen collapse under gravity, but that collapse depends on how efficiently the gas loses heat. Webb's infrared data suggests that early gas cooled faster than expected, possibly due to molecular hydrogen or trace metals from the first supernovae. That cooling accelerated star formation, altering the tempo of the universe's opening movement. Another adjustment concerns black holes. Webb's discoveries of surprisingly mature galactic centers imply that black holes grew rapidly, feeding on surrounding material like thunderous bass notes driving the rhythm. This changes not only how galaxies evolve but how light itself travels through them, affecting the brightness we observe. Each new insight adds depth to the cosmic melody, like rediscovering an instrument hidden in the orchestra. Even dark matter, long thought to be the steady metronome beneath cosmic growth, might be more dynamic than expected. Some simulations suggest that if dark matter interacts even slightly with itself, it could speed up or slow down the formation of early galaxies. Webb's unexpected abundance of massive young systems may hint at such interactions, subtle shifts in tempo that no one predicted before. The process of retuning is slow but beautiful. Scientists propose, test, and refine, sometimes finding that their old theories still hold, just in a different register. Other times, the models must change completely. It is like adjusting an ancient instrument, one that has played for billions of years, trying to understand how its resonance fills the hall of space. Each time Webb's instruments record a new deep field, filled with faint red galaxies at the edge of time, it offers a new chord to analyze. The cosmic music is not random, it follows patterns, motifs, recurring progressions that can be traced back to the earliest fluctuations of the Big Bang. But just as no two performances are identical, the universe's evolution includes improvisation, shaped by chance encounters and collisions. Scientists find comfort in this harmony of uncertainty. The universe's song is not perfectly predictable, but it is consistent enough to guide us. Each discovery Webb provides, even when it surprises, still fits within the larger melody of cosmic evolution. The tuning never ends because the music never stops. As models grow more sophisticated, they now incorporate chemical feedback, the influence of early stars enriching their surroundings with heavier elements. Webb's infrared spectra reveal signatures of oxygen and carbon in galaxies that formed astonishingly early. These findings mean that star birth was even more prolific than we thought. The first movement of the universe was not a quiet prelude, it was a symphony bursting to life. To match these revelations, cosmologists refine their equations like composers rewriting a score. They adjust rates of star formation, tweak assumptions about supernova energy, and add variables to account for dust absorption. Each correction brings theory closer to resonance with Webb's vision, each adjustment like sliding a bow across a string until the pitch aligns with the unseen truth. Even the age of certain galaxies must be reconsidered. Webb's sharp infrared eyes can distinguish subtle differences in redshift, revealing that some galaxies thought to be ancient are actually closer, while others truly belong to the dawn of time. These recalibrations echo through all models of structure formation, like a new key signature changing the mood of the entire piece. The universe, in a way, participates in this tuning. It gives feedback, sometimes quietly, sometimes dramatically. The moment a new observation challenges expectations, it forces theory to grow. This dialogue between cosmos and mind is the essence of science. We are not imposing order on the universe, we are learning to hear its own. As Webb continues to collect data, astronomers are discovering subtle variations in how galaxies align, rotate, and cluster. These small details matter, each is a harmony or dissonance that shapes the grand composition. They reveal whether dark energy truly remains constant or if it fluctuates over time, slightly altering the cosmic rhythm we've been following. In many ways, the act of tuning reflects humility. To adjust one's model is to admit that nature knows better. Scientists listen, compare, and let the evidence reshape their understanding. It is a practice both technical and poetic, guided not by control but by attention. The universe plays first, we simply try to catch the melody. When a musician tunes an instrument, they use both ear and instinct, feeling for the right vibration that brings harmony. Cosmologists do the same with data. They listen not with ears but with mathematics, translating Webb's whispers into frequencies of probability. When a model fits perfectly, it resonates like a chord held just long enough to feel complete before the next begins. These adjustments ripple through disciplines. Astrophysicists revisit theories of cosmic reionization, particle physicists rethink how matter first clumped, even philosophers of science reflect on how observation changes understanding. Webb has not merely given us new images, it has retuned the entire orchestra of modern cosmology. Each refined model brings the universe into sharper focus, but also reveals how much remains unplayed. There are harmonics we can't yet hear, dark matter interactions, dark energy fluctuations, quantum ripples at cosmic scales. These are notes still out of reach, waiting for future instruments to detect. Science advances not by silencing uncertainty but by harmonizing with it. And so, each time Webb's golden mirrors turn toward the deep sky, the process begins anew. Data arrives, models adjust, harmony returns, until the next discovery shifts the key once more. It is a cycle as eternal as the cosmos itself: tension, resolution, and renewal. The song of the universe is not one of perfection, but of perpetual tuning. This endless tuning mirrors life itself. We, too, adjust our understanding as new experiences challenge what we thought we knew. The music of existence evolves as we learn to listen more deeply. Like the scientists reworking their models, we refine our truths, finding harmony not by being right, but by staying open to change. Webb's discoveries remind us that the universe is not a static composition, it's a live performance, ongoing, improvisational, full of unexpected crescendos. Our models are the sheet music, ever revised to keep up with the sound of creation. Each observation, each adjustment, brings us closer to understanding the melody that began billions of years ago. And as that melody stretches across time and space, echoing through stars, dust, and silence, humanity listens more carefully than ever before. The universe hums, and our instruments tremble in response. The tuning continues, not toward perfection, but toward connection. For in learning to hear the universe's song, we are, in truth, learning to hear ourselves. In the vastness of cosmic time, galaxies too have their childhoods, filled with fiery tempests and unrestrained energy. They grow from chaotic clouds of gas and dust into elegant spirals and smooth ellipses. This transformation, though stretched across billions of years, can be imagined like a bridge, a shimmering arch of time that connects the restless beginnings of the universe to its graceful present. On one side, there is noise, heat, and violence. On the other, quiet rhythm and balance. The early universe hums with creation's fever, while the mature one sighs in long, even breaths. In the earliest ages, young galaxies burned too brightly for their own good. They formed stars at rates that would seem impossible today, thousands each year, until their fuel ran thin. Their light outshone the calm galaxies we know now, spilling radiation into the blackness and changing the cosmic fog that once filled space. But over time, that wild energy cooled. Gravity became the sculptor, and the galaxies began to settle, their frantic births giving way to structure. Slowly, spirals formed, arms unfurling like ribbons on a cosmic sea breeze. That moment of calm, though distant, wasn't the end of activity, it was transformation. Just as a young river rushes over rocks before deepening into a steady flow, galaxies learned to conserve their rhythm. They still created stars, but more thoughtfully, in harmony with the gravitational dance of their parts. This shift was not abrupt, it unfolded gently, like dusk fading into night. What had once been storms of light and dust began to take shape as serene, glowing disks floating through the void. When astronomers peer into deep fields of the early universe, they see both the youth and the maturity coexisting. Some galaxies still blaze with restless creation, while others already show signs of order. It's as if the universe itself was learning, experimenting, failing, refining. That bridge between chaos and calm is filled with beauty, because it holds both the energy of what was and the promise of what will be. Even the faintest of these ancient lights hums with the story of transition. The James Webb Space Telescope captures this bridge better than anything before it. In its infrared gaze, we see galaxies caught mid-growth, spirals half-formed, arms emerging from clouds, dust glowing where stars were just born. It's like watching a child learn to walk. Each wobbling structure tells of physics still finding its rhythm. These snapshots remind us that evolution, even on the grandest scales, is rarely clean or simple. It's full of overlapping notes, a cosmic improvisation still echoing today. Many galaxies in this stage look strange to our eyes, irregular, patchy, stretched by invisible forces. Yet within that apparent confusion lies a pattern that only time can reveal. As they merge and spin, the chaos softens, lines form, and stability takes root. Astronomers compare these shapes to blueprints of what mature galaxies will later become. Every jagged outline hints at the smooth spirals and grand ellipses yet to come, waiting for gravity's patient correction. Dust, too, plays a quiet but vital role in this transition. Once dismissed as cosmic debris, dust now reveals the rhythm of star birth and decline. In the bridge between wildness and calm, it acts as both shroud and cradle. It hides newborn stars even as it helps them form, softening the brilliance of the past while shaping the light of the future. In Webb's eyes, dust glows like embers, signs of energy spent wisely, rather than wasted. Scientists often describe this period as a cosmic adolescence, where galaxies are neither completely wild nor fully mature. Their structures wobble between instability and grace. They flicker with bursts of star formation, but also begin to regulate themselves. Supernovae and black holes feed back energy into their surroundings, not to destroy, but to balance. It's a self-tuning process, where feedback replaces frenzy, and chaos gives birth to coordination. At the heart of many of these transitional galaxies lie small but active black holes, regulating their environments like cosmic conductors. When these black holes feed, they blow winds that sculpt the galaxy's gas. Too much energy, and the galaxy cannot grow; too little, and it suffocates under its own density. But the right balance brings harmony. Through such delicate cycles, order emerges naturally, proving that even destruction has a place in creation's song. This balancing act extends across unimaginable distances. Galaxies don't evolve in isolation, they are influenced by neighbors, collisions, and the slow tides of cosmic expansion. When two galaxies approach, the result might seem catastrophic: stars flung wide, arms torn apart. Yet in time, those collisions forge beauty: elliptical galaxies full of old stars, glowing softly like aged lanterns. The bridge from wild to calm is paved with such interactions, each one an act of both loss and renewal. Observing these moments lets scientists trace the story of galactic identity. They see how shape and structure emerge from the interplay of gravity, light, and time. Each spiral arm tells of balance regained after turbulence. Each glowing core marks a compromise between expansion and control. The galaxies we see today, majestic, steady, and bright, are the quiet children of that long, turbulent era. They carry in their light the memory of the bridge that built them. In many ways, this story mirrors life itself. Growth often begins in disorder, guided by unseen forces that only later make sense. Just as a mind matures from chaos to clarity, galaxies too learn to balance their internal storms. This slow journey toward calmness gives meaning to the passage of cosmic time. It's not simply about reaching order, it's about how the universe learns to hold stillness without losing its spark. The bridge also reminds us that nothing truly ends in the cosmos. The calmness we see now is not a conclusion, but a pause. Even the most stable galaxy continues to change, stars die, new ones form, and gravity subtly reshapes the dance. What seems serene from afar is full of quiet movement. The calm is never absolute, it's an ever-renewing state, balanced between the memory of chaos and the promise of new beginnings. There's comfort in knowing that this pattern, wildness giving way to grace, echoes at every scale. Atoms, stars, galaxies, even universes follow the same rhythm of becoming. Turbulence teaches structure, silence refines sound. The bridge between the two is where growth truly happens. Webb's lens doesn't just show us distant worlds, it reveals this eternal process in all its shimmering patience. When astronomers model these transformations, they often find that nature prefers compromise over perfection. The most beautiful spirals are slightly asymmetrical. The most luminous galaxies have scars from collisions. These imperfections tell the truth of how balance is earned. Calmness, in the universe's language, is not the absence of struggle, it's the harmony born from it. Every flaw becomes a verse in the universe's slow song toward stability. The ancient light that Webb collects doesn't simply show us forms, it shows us emotions written in starlight. The reckless confidence of youth. The trembling of transition. The deep exhale of maturity. These galaxies, millions of light-years away, mirror our own journeys of growing up, of finding stillness without surrendering wonder. In their glow, we see reflections of ourselves, tiny, fragile beings crossing our own bridges between storm and serenity. And so, when we gaze upon those distant, half-formed galaxies, we aren't just looking at history, we're watching time's art unfold. Each soft curve, each faint swirl, is the echo of physics finding its footing. Somewhere in that story lies the origin of our own galaxy, and by extension, our world. The calm we inhabit now was born from that same wildfire. We are, in every sense, the children of that transition. As billions of years stretch onward, galaxies continue their slow drift toward stillness. Star formation slows, light softens, collisions grow rarer. The bridge never fully ends, it extends forever, fading into deeper peace. Yet even then, faint sparks continue to bloom in forgotten corners of space. The universe never stops whispering new stories, even as it grows quieter with age. This is why the cosmic bridge holds such poetry. It reminds us that transformation isn't a single act but a symphony of moments. Chaos and calm are not enemies, they are partners, trading places in an infinite rhythm. Through Webb's eyes, we witness the universe rehearsing this timeless melody, its notes carried across eternity by light itself. Perhaps that's the truest wonder of all, that in a universe so vast, the same laws that shaped ancient galaxies also guide our lives. The bridge between wildness and calm runs through everything, from the birth of stars to the quiet of human hearts. To look into the night sky is to see that bridge stretching on, glowing softly, inviting us to walk across it slowly, gently, forever learning how to be still. The universe, once loud with collisions and flares of young stars, now drifts into a gentler rhythm. The chaos that once defined its earliest moments has dimmed, not vanished, but softened into memory. Galaxies, which were once fiery children, now glide gracefully through the quiet dark, their arms extended like tired dancers after a long performance. This is the universe's twilight hour, a slow exhale after an eternity of becoming. Light still shines, but it is no longer a roar, it is a whisper. Every glimmer that reaches us carries an echo of that ancient wildness, faint but eternal. The photons that left their galaxies billions of years ago now touch our eyes with stories of storms long stilled. It's a kind of farewell, a gentle closing of a chapter written in fire. Yet there's tenderness in that farewell, because what once was violent gave birth to everything serene. The same forces that tore and fused also created structure, harmony, and the delicate balance we now see. The stars no longer burn with the reckless speed of youth. They live long, quiet lives, slowly sipping their hydrogen, glowing in patience rather than frenzy. The vast nebulae have thinned, their bright tendrils fading into starlit fog. The explosions that once thundered through the void now happen less often, replaced by the soft hum of cosmic background radiation, the last breath of a universe that learned peace. It is strange to think that silence, once unthinkable, became the natural state of things. The galaxies drift apart, yes, but not in loneliness. They are simply giving each other space to rest. The gravitational bonds that once pulled them into collisions have weakened under the universe's expansion, leaving each to float quietly in its own domain. What was once a crowded playground of creation is now a serene sea of solitude. The James Webb Space Telescope captures these fading embers with a reverence that feels almost human. Its golden mirrors collect the last warm sighs of distant stars, painting portraits of cosmic maturity. Each image is a goodnight note from the past, a light so old that, by the time it reaches us, its source has already drifted into stillness. Webb doesn't just observe, it listens. It listens to the soft closing notes of a song that began before time had meaning. Astronomers studying this era speak in whispers, as if afraid to disturb the peace. Their instruments no longer record the crackle of frantic energy but the soft pulse of structure in equilibrium. Dark matter halos cradle galaxies in stable silence. The intergalactic medium, once boiling with radiation, now cools into near emptiness. The universe has learned the art of restraint, of holding itself together without force. Even in this calm, small dramas continue to unfold. Stars still die, collapsing into white dwarfs, neutron stars, or black holes. But these endings feel less like tragedies and more like rest. Each fading star contributes to the long, slow cooling of the cosmos. Their remnants, quiet, dim, and dignified, float as monuments to the vigor that once was. The universe, in its late age, has found peace through impermanence. If we could stand outside of time and look across cosmic history, the contrast would be breathtaking. From the first explosive bursts of starlight to this present hush, it's as though the universe has exhaled from chaos into contemplation. Where there were once dazzling fireworks, there is now a vast, deep calm. Space itself feels older, wiser, a grand being that has finally learned stillness after a life of storms. This is not a sad stillness. It is the kind that follows completion, like the silence after music fades. The galaxies hum faintly in infrared light, their older stars glowing red and cool. They no longer need to prove their existence through brilliance. Their beauty now lies in their endurance, in the quiet symmetry of their survival. They are not dying, they are resting. From this perspective, the ancient chaos takes on new meaning. It was not random or cruel, it was necessary. Every violent birth, every shattered cloud, every blazing supernova built the ingredients for peace. The calm we witness now could not exist without the storm that came before it. Creation and destruction, noise and silence, these were never opposites, only phases in the same great breath. Even the cosmic background radiation, faint and uniform, carries this lesson. It is the echo of everything, the universe's first cry, now softened into a whisper that fills all of space. That faint glow is the ultimate lullaby, the proof that even chaos, when stretched across time, becomes harmony. It reminds us that energy never vanishes, it only changes tone, shifting from thunder to hum. Webb's instruments see the past as if through time's veil, revealing galaxies that were once children but now appear as ghosts of themselves. Some are mere smudges of red light, their stars too old to shine brightly. Yet even those faint forms tell of survival. They've outlasted collisions, expansion, and entropy's creeping hand. In their stillness lies the universe's ultimate triumph, persistence. We might think of this cosmic goodnight as the universe tucking itself in. Dust settles, stars fade, and the vast tapestry grows dim. But within that quietness lies a promise. New stars will still emerge, slowly, patiently, from the leftover gas of ancient ones. Even in decline, creation continues in subtler, more thoughtful ways. The universe has not stopped, it has merely slowed to a tempo that suits its age. Time itself seems to move differently here. Where once everything happened in frantic bursts, now the ticking of cosmic clocks feels endless. A billion years passes like a moment. Entropy advances with grace, spreading not destruction but stillness. It's a slow unspooling of energy into evenness, a quiet surrender that feels like peace, not loss. Human minds struggle to grasp such scales. To us, silence feels like an end, but in cosmic terms, it's simply another kind of existence. The star's fading light does not mean the story is over, it means the story has matured. The universe has learned to speak softly. The same fabric that once roared with fire now whispers with warmth, inviting reflection instead of awe. If one listens closely to the deep data Webb sends back, it's as though the cosmos hums in sleep. Not dead, not gone, just dreaming. The galaxies drift like thoughts across a resting mind. The black holes, once devourers, now rest quietly, their hunger slowed by the thinning of matter. The vast filaments of dark matter remain as invisible scaffolds, holding the dream together, even as light dims. Astronomers will continue to look back, searching for the echoes of the beginning, but what they find most often is quiet continuity. The universe does not forget its youth, it carries it gently, folded into every particle of light. The violent births, the bright fusions, the grand collisions all softened into memory. It is the ultimate story of transformation, of energy learning to be gentle. Perhaps that's the secret grace of the cosmos, it knows when to rest. After all its labor, all its expansion, it drifts toward calmness not because it has lost its fire, but because it has fulfilled its purpose. Stars no longer need to blaze to prove they are alive. Galaxies no longer need to crash to grow. Everything simply exists, balanced between motion and stillness. And as the light continues its journey toward us, even across unimaginable distances, it carries the essence of this peace. Each photon, ancient and fragile, has crossed the bridge from chaos to calm. When it finally reaches Earth, it tells us that beauty does not need to be loud. It can be found in the slow fading of brilliance, in the enduring quiet after creation's symphony has played its last notes. To look at those dim galaxies through Webb's golden mirror is to look into time's own heart. The light is weak, but its story is vast. It whispers that the universe does not fear endings, it turns them into art. Every quiet corner of space is a canvas painted by time, glowing faintly with the residue of infinite becoming. The silence is not empty, it's full of memory. For the scientists who study these faint signals, the work feels sacred. Each pixel of infrared light is a relic, a fossil of the first moments of existence. They read it like monks reading ancient scrolls, tracing the fading ink of creation's story. In their data, they find humility, a recognition that even the smallest remnant of light carries wisdom older than galaxies themselves. And for us, gazing upward from our tiny world, this cosmic goodnight holds comfort. The same physics that cooled the universe now cradles our lives in gentle gravity and warmth. The peace above mirrors the quiet we seek within. To watch the stars fade is not to mourn them, it's to join them in stillness. We are made of their dust, their silence is ours too. There will come a time, unimaginably far ahead, when even the last stars will flicker out. But that moment, too, will not be a tragedy. It will be the final sigh of a masterpiece, a long, graceful fade into darkness. And who knows? Perhaps even then, the universe will dream again, shaping new light from its own quiet ashes. Until that time, we live in the glow of a universe that has learned calm. Every sunrise, every night sky, is a continuation of that soft farewell. The chaos that once ruled has not vanished, it sleeps beneath the surface of all things, waiting to remind us that peace and wildness are forever intertwined. And so, the universe hums its lullaby. Galaxies drift. Stars cool. Space expands gently into the unknown. The song of creation has become a whisper, long and low, but still full of grace. It's not a silence of absence, it's the silence of fulfillment, the kind that comes only when everything that needed to happen, has. The James Webb Telescope will keep listening, sending us these murmurs from the deep. Its instruments are our ears pressed to the fabric of eternity. Each faint spark it records is the universe saying goodnight again and again, softly, beautifully, endlessly. And when we look up at that night sky, knowing what it truly holds, we too can whisper back. We can say thank you for the chaos that built us, for the calm that sustains us, and for the quiet that one day will welcome us home. The universe, vast and ageless, has earned its rest. And in its stillness, we finally understand, all things, no matter how wild, one day learn how to sleep.